Esteemed Dr. Sanjay Dhoble, esteemed Dr. Sanjay Dhoble, a distinguished scientist from RTM Nagpur, Dr. Sameer Kalia, head of the department and the convener of this event, Dr. Neeru Gupta, coordinator of the event, Dr. Ajay Kumarji, co-organizing secretary, my dear colleagues and dear participants, a very good morning to all of you. It's my pleasure to greet you all on the second day of this 7-day faculty development program, the recent developments in physical science. Dear students, dear participants and delegates, to have a joyful and energetic day ahead, let us tune our minds with the vibes of DAV Khan. So I request Dr. Naina Handa to kindly play DAV Khan. Dr. Naina Handa, please.
अविरल निर्मल सलिल सदय ज्ञान प्रदायिनी ज्योतिर्मय हो चहु दिशि उद्घोष अभय दिए विजय जय दिए विजय जय प्रबल प्रवाहमयी नित नूतन जीवन दायिनी सदा सनातन वेद प्रणीता परम पुनीता ये धारा अक्षय दिए विजय जय दिए विजय जय दयानंद से प्रेम भक्ति ले हंसराज से त्याग शक्ति ले धर्म भक्ति का राष्ट्र शक्ति का हो दिन मान उदय दिए विजय जय दिए विजय जय सुख समृद्धि इसकी लहरें प्रेम शांति इसके तट ठहरे सघन शांतिमय प्रबल क्रांतिमय लिए अटल निश्चय दिए विजय जय दिए विजय जय।
Now I request Dr. Sameer Kalia to kindly welcome our guests and the participants. Dr. Sameer Kalia, please.
Thank you, Dr. Maninder. I'm really thankful to you to give me this opportunity. Esteemed Dr. Dhoble from RTM University, Nagpur, my fellow colleagues, coordinator of this event, Dr. Neeru Gupta, Dr. Maninder Kaur, the organizing secretary, Dr. Ajay, who is co-organizing secretary, Dr. Vibha Chopra, who is the session coordinator today, and my fellow participants. I extend a very warm welcome to you all and a very good morning to you. I'm feeling extremely privileged in introducing you to the speakers of the day. In the first session, we have esteemed Professor Dhoble. I was going through his resume, and believe me, it's unending. It's unending. I'm really overwhelmed to read his resume, and I'm looking forward to listen to him. That means I'm sure that his lecture is going to be extremely useful for all of us. He did his MSc from Rani Durgavati University, Jabalpur in 1988 and completed his MSc from Nagpur University in 1992. He's presently working, completed his PhD from Nagpur University, in 1992. Presently, he is working as professor in RTM University, Nagpur. Dr. Dhoble has 30 years of research experience and is among the top 2% of the scientists of the world, as per the list published by the scientists from Stanford University. He works in the field of synthesis and characterization of solid-state lighting materials for solar cell efficiency enhancement, as well as in radiation dosimetry. Dr. Dhoble has 41 patents to his credit, 41 published patents to his credit, and hefty number of 676 research publications in journals of international repute. His H index is 35 and his I-10 index is 270 with more than 9,000 citations as per Google Scholar and 7,000 citations in Scopus. He has edited and authored 16 books. Editor of journal Luminescence, the Journal of Biological and Chemical Luminescence, is discharging duties as editor for this journal, published by John Wiley & Sons. He's a faculty research awardee in 2018, and he's among top 10 researchers in India in physics. The list is unending. I may take the whole session if I'll start reading the complete resume. I have had the opportunity of listening to him earlier in 2018 when he was with us in our college for a one-day seminar, and I can assure you that he has got that marvelous ability to connect with the audience. His lecture is so beautifully composed that you'll not be able to blink your eyes. If you blink your eye, you'll be missing something important. So I welcome you, Dr. Saab, to our institution once again, this time in a virtual way. I'm really very thankful to you for accepting our invitation and being a part of this faculty development program. I'm sure that your talk today will be beneficial for all of us. That will be enlightening, and that will definitely create ripples in our mind as far as this field of study is concerned. I'm really thankful to you from the core of my heart once again, sir. The second speaker of the day is Dr. Bindiya Arora. She'll join us later in the session. She has done her PhD from Delaware University, USA. She's working as a associate professor in the Department of Physics, Guru Nanak Dev University, Amritsar here. And she works in the field of computational physics and has got more than 50 publications in reputed journals. But the main what you can say, the quality of Dr. Bindiya Arora, let me tell you that she's the most associating teacher as far as the Department of Physics here in Guru Nanak Dev University is concerned. She's such a approachable teacher that she's the most favorite teacher of the students here in the department. Listening to her is also sheer pleasure. She'll be training us on LaTeX. LaTeX is the modern day language for writing research papers and other writings as well. But mostly it's being used by the top researchers for writing their research papers. And she'll train us in that in 2 sessions, one today and one tomorrow. And I'm looking forward to get training from her as far as the LaTeX is concerned, although she's not present, but I extend my warm welcome to her as well. I'm sure that these 2 lectures are definitely going to be enlightening for us. I'm really thankful to you all participants for once again joining this FDP. Without you, there is no fun of arranging any event. Your overwhelming response to this is really humbling for us. Thank you. Thanks for joining. I thank Dr. Dhoble and Dr. Bindiya once again. And now I hand over the mic back to Dr. Maninder for conducting the session. Thank you.
Thank you, Dr. Smith, sir. As sir has already told us that Dr. Sanjay Dhoble, he is amongst the top 2% of the scientists. So to have a look at the other achievements of Dr. Dhoble, I invite Dr. Vibha Chopra to share the other achievements of Dr. Dhoble and to carry on the session ahead. Dr. Vibha Chopra.
Thank you, ma'am. Good morning, everyone. I, on the behalf of PG Department of Physics, DAV College Amritsar, extends a warm welcome to each and everyone who has joined us on the second day of FDP. I feel privileged to introduce our eminent speaker, Dr. Sanjay Dhoble, Professor, RTM Nagpur University. I really feel elated to introduce the great scientist with not only impressive biodata, but a realistic, dedicated, and hardworking spirit and a pioneering spirit. So I think Smear sir has already told you much about Sanjay sir. I again repeat that Dr. Dhoble, he stands among the top 2% scientists in the world in the prestigious list published by a team of scientists in US Stanford University in one of the highly rated journals, PLOS Biology. And he has published 41 patents, out of which 9 patents have already been granted. One is South Korean patent, 6 patents are Australian patents, and 2 Indian patents have been granted in the field of luminescence, and few of them are already been granted and published. He has more than 676 research papers that are published in Scopus indexing journals, and his H index is 35, and he's having 7,186 citations on Scopus. Doble's citation on Google Scholar is 9,144 and H index is 40, and his I-10 index is 270. So he has already guided 65 students for PhD. So I think friends list is too long to mention. Now I invite Dr. Sanjay Dhoble to please come and enlighten us all with the knowledge of nanoscience and nanotechnology synthesis, properties, and its application. Over to you, sir.
Hello. Yeah. इसको बढ़ा दो फुल स्क्रीन
वहां से शेयर किया था आपने स्क्रीन?
हाँ
स्क्रीन शेयर.
हाँ मैडम my screen is clear. Hello.
Yes, sir, you are audible.
And my screen is
Yes.
okay. Thank you. So I'm first of all thanks Honorable Dr. Rajesh Kumar, Principal of the DAV College, and convener of this FDP, Dr. Sameer Karla, and course coordinator, Dr. Neelu Gupta, organizing secretary, Maninder Kaur, and co-organizing secretary, Dr. Ajay Kumar. And special thanks to Dr. Vibha Chopra, all of you inviting me for this presentation in the FDP program. I will try to explain some initial idea about the nanoscience and nanotechnology for the new researchers, especially from the those are just enter in the field of the research, as well as he or she want to the work in the nanoscience. So my title of my talk today is the nanoscience and nanotechnology, synthesis, characterization, and applications. Okay, so this is my address, Dr. Sanjay J. Doble, Professor, Department of Physics, RTM Nagpur University, Nagpur. This is my university, and the university accredited by A grade. And this is my university is completely glow in the LED lighting. I'm also working on the LED lighting. Then I'm very much interested in this picture. So this is the whole university in the different color of the LED lightings. So nanoscience and nanotechnology. Today it is very difficult. You can work in the only one subject. If you can work in the 2 or 3 subjects together, so it is possible. So this is the interdisciplinary topic. So combination of chemistry, physics, electronics, Ayurveda, medical, and engineering. Similarly,
Excuse
also,
me, sir.
Yeah.
Sir, your screen is not visible.
Okay.
Have you shared your screen?
Okay. Now it is visible. Yes. Yes, ma'am.
No, not it is.
No, sir.
Okay, 1 minute. 1
Kindly
minute.
share the screen.
No, yeah. Okay. Just 1 minute. 1 minute, please. Okay, I go back. Yes, it is clear.
Yes, sir, it's visible now.
It is visible now.
Yes, sir.
So now this is a full screen. Is visible. Full screen is visible.
Yes, sir.
Okay. So nowadays it is the very difficult. You can work in the only one one subject. Just you are anybody working on the chemistry, electronics. I'm working the physics. So this is the limitation of work is possible. But if you can work with the some other subject, so it is possible some part in the one subject, some part in the other subject, and you can correlate. And possible is the high impact factor paper, sometimes the patent, or sometimes is the product also. So this is the nowadays it is interdisciplinary research is more important. So nanoscience and nanotechnology, one of the subject, it is the promote the interdisciplinary topic. This is the communication of the chemistry, physics, electronics, Ayurveda, medical, and engineering. So, and chemistry is playing the role of the synthesis, but it is not a only for the chemistry people play the role of the synthesis. Physics people also work in the synthesis. Physics people is the chemistry, similarly the chemistry, electronics or other subjects also play the role of the characterization of the material, role of the electronics and engineering and analysis of the nanomaterial. So this is the different subject, it is the expert in the different field, but if you can work together, then it is possible the interdisciplinary work. So today's my presentation only on the base of the how to work in the interdisciplinary subject with help of the nanoscience and nanotechnology. So why nano? The nanoparticle differ their property with respect to bulk. Just you can consider the bulk particle and nanoparticle, then its characteristics is so many changes. So highly energetic, highly active. So just you can distribute the particle on the basis of the particle size. So size in the micron, then you can consider this is the bulk particle, 100 to 500 nanometer, then it's called a submicron. 10 to 100 nanometer is the nanoparticle, and 1 to 10 nanometer it is the quantum dot. So this is the quantum dot. Again, it is very highly, and in future it is possible in the pico particle also. So then it is a generation is the changes bulk to submicron to nanoparticle and quantum dot in future, and any other particle is possible. So this work is very important. So changes during the bulk material to nano. So what is the property of this material changes? Material, the optical property changes, crystal shape change, conductivity, magnetic property, melting point, chemical reactivity, surface property, and mechanical strain also. So all this property, it is directly related to the particular type of the application. So if you can prepare the material, and then you can enhance this type of the property only just changing the particle size from the bulk to nanoparticle. So this material, it is a highly potential and is useful for the very good application, and possible is converted in the product also. Now is the very much demand. So many people are working on the research, but how is the product? So with help of this, you can convert your material in terms of the product also. So just everyone know is the 1 to 10 nanometer is the nanocrystal and cluster also, and it is called quantum dot. And again, it is the ceramic oxide 1 to 100 nanometer. It is the it is called the nanomaterial, nanowires, nanotube, nanoporous solid, 2D array, and array 3D structure also. So this is the different type of the particle with the on the basis of the it is the structure as well as to the particle size. So what is the size effect in the of nanomaterial? It is a more important question, and this is the very common to all the participants. The size of the nanoparticle has a great influence on their property. When a particle is in the bulk state and compared to its size and its micro scale, and there is not much difference in its property. But however, when the particle size is less than to the 60 nanometer, actually the 1 to less than to the 100 nanometer, it is called the nanomaterial, but particle size actually less than to the 60 nanometer, the property changes significantly compared to the bulk state. And in this scale 1 to 60 nanometer our quantum size effect decided the property of the particle such as the chemical, thermal, mechanical, optical, electrical, magnetic, and so on. So all the some property, it is drastically changes. So this is the main potential of this the nanomaterial. So this is the all range is very important of the particle size. Just as a simple example, just you can see the 1 meter size basketball is the 100 millimeter, and this B is a 10 millimeter, and so on. And lastly is the atomic structure in the terms of the 0.1 nanometer. So with help of this one, you can imagine what is the scale of the nanometer, and according to you can find the is working. So here it is the colloid, nanoparticle, macromolecules, or inorganic colloids, or biocolloids. So all these figures, just you can in the bacteria, virus. Now in the coronavirus is the big problem. It is the size is around 125 nanometer. So this is the virus size is the 100 nanometer, and this is the bacteria size 1 micrometer. So all this picture, if you mind, that you can easily work in this size type of the material. This is very important. So size effect. So just you can see the gold, it is in form of the solid. It is completely yellow color. But you can decreasing the particle size, then particle of the gold particle 300 to 500 meters, this is the violet color. Then this is the drastically changes, and in the quantum dot are less than to the 10 nanometer is completely red color. So this is called the red gold. It is very costly. So size effect constitute a particular and it is important aspect of the nanomaterial. The effect determines the size pertinent to evaluation of the structure. So this is the thermodynamically, electronically, spectroscopy, electromagnetic or chemical feature of this finite system will be the changes. So just everyone is concentrate what is the particle size of the material, what is the color, and it is the spectroscopic property as well as to the it is the potential application of this material is more important, and this is the part of the nanoscience and nanotechnology. So suppose one material in the bulk form and we can convert it in the nanoparticle. So it is increasing the chemical reactivity. It is increasing the chemical reactivity. Sometimes anybody working in the nanomaterial or some of the student in the BSc or MSc, so nanomaterial is a very high potential material. But why? Why it is a high potential material? So it has some answer for the student. Sir, it is the chemical reactivity changes in the particle size changing from the bulk material to nanomaterial. Simple example is the gold nanoparticle. Antibacterial activity. So this is a very popular nowadays in the pandemic season. Everyone mask this PPE kit or some glass, some is the instrument. It is also totally coated by the nanoparticle, and that is very important. So this antibacterial activity is nowadays is very important. Only changing the particle size bulk to nanoparticle, and number of metal used as a antibacterial as a nanomaterial used as an antibacterial activity. Mechanical property. Optical property is very important. Silver nanoparticle quantum dot is also one. Electrical property, tunneling the current, and magnetic property also. So just is the you see that the first is the very small size of the pen drive. It is the capacity is the very high. Very less, but now it is particle size of the instrument decreasing, but magnetic property it is also changes. Then one small pen drive, it is the capacity is much more. So this is the changes by only further due to the particle size, and this is the in terms of the nano or quantum dots. So just you can see here the gold nanoparticle, it is a variation with decreasing the particle size. So at nanoscale, gold particle exhibit purple color different from the bulk, which was yellow colored, and this color changes is attributed to the change in their band type from the continuous to the discrete due to the confinement effect. So only for the particle size decreasing, then it is the property that changes. But what is the physics? What is the science behind this? So only for the particle size changes, that corresponding the band gap, it is also vary, and this band gap it is the totally responsible for the it is the property. This is the much more important. Just simple example, the metal, it is a conductor, there is a zero band gap, but insulator is the large band gap. But in the semiconductor, band gap is the less. So what is the difference between the semiconductor, insulator, metal on the basis of band gap theory? This is the answer. But what about the nanoparticle? So nanoparticle is the band gap. It is also changes according to this one. Just you can see here, particle size is decreasing. That corresponding the band gap also the increasing as compared to the semiconductor. So total role of this particle, it is a totally spectroscopic property, and this is the changes the increase in the band gap. So if particle size decreases, then band gap is the increasing, and how to reduce the particle size by a particular method. This is the method, it is the green method, this is the chemical method, or any mechanical method, this is a different way. But particle size decreases, then band gap is the increasing. So this then it is a physical property or chemical property is drastically changed, then we are confident to explain some nanoparticle or quantum dot is the highly potential particle. So this is the correct answer for this. So classification of nanoparticle based on their dimension, the production of conventional product at the nanoscale currently help that will continue to will the economics progress of numerous country. But suppose that you can prepare some nanoparticle. So this what is the total requirement of this is the synthesis? What type of this is the property changes? What is the changes in the role of the device? It is much more important. So nanoparticle were classified depending on their crystalline form and chemical composition. However, the you can change the particle size so that corresponding, so new scheme of the classification is possible. And for the nanoparticle, which include the recently developed the composites such as the 0 dimension, 1 dimension, 2 dimension, and 3 dimension nanoparticle. A 0 dimension means it has only one dot. 1 dimension is the variation along to the one axis, just like that. This is the example. Again, we are just explain. This is the advance in the imaging technique. Atomic, you can characterize by this atomic force microscopy and scanning electron microscopy. And this is the gold particle. Just you can see the size of this gold particle in the nanoscale. So just is the nanomaterial in the 0 dimension. This is the figure number A. Just is the dot. But it is a 2D, it is figure number B. It is increasing in the one x-axis, 2 axis only. But silver nanoparticle, one direction, it is the figure is the C. It is the 1 dimension only for. And again, it is a 1 dimension. This figure is the D. But it is the 3D direction. It's just like this flower type of the structure. This is the F. It is an example of the 3D. So with help of this material morphology, it's a property, it is a totally changes. So number of scientists try to prepare the very good material in the different form, and on the basis of the spectroscopic characterization, it is the application is decided, and then it is considered 0D, 2D, 1D, or 3D like this one. So this classification is highly dependent on the electron movement along the dimension in the nanometers. For example, electron in the 0 dimension nanomaterials are entrapped in the dimension space, whereas the 1D. But nanoparticle have the electron that can move along to the x-axis only. But which is the less than to the 100 nanometer? Likewise, the 2D, 3D nanometer have an electron movement along to the xy axis and XY, Z axis respectively for the 2D XY and 3D for the XY Z axis. So this is the totally classification of the according to the morphology of the particle, and this is the variation along to the XY Z axis, and is the one dot. So this is the 0D. So this is the main role of the structure of this nanoparticle. Again, it is some example. You can crush it and just you can find out this much. So in the one big piece, it has so many types of the nanoparticle are possible. And then property of the control the surface area. Again, it is very clearly explained the 0 dimension. It is the only dot 1 dimension. It is a 1 direction. This is the variation. 2 dimension the XY axis, and 3D dimension it is the 3 axis. So this is the example for this. Again, just you can see this is so many example. So this example you can imagine. So you can easily possible to work in this field of the nanomaterial. Okay. So just carbon nowadays it is very highly potential application in the different field. Why? It is the graphical structure, or it is a spectroscopic structure. It is completely vary. Then on the basis of carbon, fluorence is possible, nanotube, graphene, and graphite, carbon, and so many type of the diamond also. And so this is the only part of the carbon, only for the changing it is the dimension. So this is the role of the nanoscience. And then it is with help of this, some device is formed by using some technology. So this is called the nanotechnology. So just optical property of the material, it is also changes. You can change that. This is the picture you can see here is the color is the changes much more. So particle it is also changes due to it is the band gap. It is also variation. But the British Standard Institution proposed the following definition of the scientific term that have been used. So this is the very important. Sometimes for the student or some research is very important for what is the nanoscale? Approximately 1 to 1000 nanometer size is range, but this is not the 1 to 1000 nanometer. This is the micron size. But 1 to 100 it is the nanoscale. But major role only show this particle less than to the 60 nanometer. Nanoscience, nanotechnology. The nanoscience is the science and study of matter at the nanoscale that deal with the understanding their size and structure depending on property and compare the emergence of the individual atom or molecule or bulk material related to difference. This is nanotechnology also similarly, and again is the nanomaterial. So many people consider I'm working on the nanomaterial. It is not a new thing. Just this person prepares the material in the nanoscale. and that corresponds to its property, it is the changes. So if someone is the working the micron and someone is the working the nanomaterial, both are the same, then it is the interest in this size is depend on. So if anyone is working the nano scale or micron scale, but it is the application, it is the characterization is totally discussed. So nanomaterial with any internal or external structure on the nanoscale dimension. Nano objects, similarly the nanoparticle, nanofiber, all these words are important. Nanocomposite, nanostructure, nanostructure material. So the use of the various definition along across the different jurisdiction act as a major hurdle to regularize the effect. So therefore, it is just you can correlate with the dimension and particle size. So nanotechnology. What is the history of nanotechnology? Nanotechnology involves the synthesis and application of the material in the dimension of the order of billionth of the meter, 1:10⁻⁹ meter. And this categorized then under ultra-fine particle. And with help of this one, it is the electronic structure, reactivity, thermal, mechanical property, everything maximum property of the changes we are already discussed in the earlier slide. And then it is the nano with help of this particle use and what some technology you can refer. So it is possible, it is converted in the particular device form by using the nanomaterial. So it is called the nanotechnology. Again, it is some natural thing. Just you can see here, it is highly potential. It is the color is not sprayed or not decay. So it is the only for the nanoparticle are used. So this is the natural thing. So this is the already this is the natural thing. Just you can see here is the total. The nanoparticle are put. This is also the example of the history. It is a nanoparticle. Then till date, it is the color. It is also same. It is not the changes. Now this is the example only for the nanotechnology. This you can see here. So all this is important. So this is the some of the example particle size, spectroscopy, and it is the structure. But now I'm concentrated on the synthesis of the nanomaterial. So this is the again important part in this my talk. Size of the particle is a nanoscale, then it is called the nano. You don't confuse. Nano means something new. Only for the size of the particle in the nanoscale and quantum of 1 to 10 nanometer. So just you can put in your mind and you can work very easily in this nanomaterial field. So just the why nanomaterial is possible here. So just you can see here, the material scientists are conducting the research in the novel material and just find out here so better property, more functionality, and low cost than the existing one. So several physical, chemical methods have been developed to enhance the performance of the nanomaterial. And this is the important of the enhance the performance of the nanomaterial. So it is the particle size and it is the distribution. So just you can see here in the general, two methods used. This is the already everyone is the top-down method and bottom-up method. I'm not discussing much more in this method. This is the well-known by the everyone for the new researcher. And just you get top-down, this is the mechanical crush, chemical for etching, thermal, laser ablation, and bottom-up is important. It is a chemical, electrochemical like this one. But this technique is the bottom to up is the green synthesis important. So in again, we will try to explain the green synthesis by plant extraction, fungi or some bacteria. So this is the very important in this nanomaterial synthesis. So in the top down method, just you can see the bulk material, you can crush it and make it the smaller. So this is the top down method. And it is the main part is the crushing, milling and grinding. So here it is the significant impact of the physical property. And you can crush it. Surface is the chemistry of the nanostructure and the material. It is well known that the conventional top-down technique can cause significant crystallographic damage to the process pattern. So it is a very important for this purpose. But it is the bottom to up, atom by atom, it is increasing. Molecule by molecule, it is increasing. Cluster by cluster, it is increasing. And it is converted in the bulk form. So this route is the more often use of the preparing the most of the nanoscale material with the ability of the generate a uniform size, shape, and distribution. So this is the very important. So synthesis of this nanoparticle. So this particle is the and then is the morphology, it is the purity, it is the quantity, and it is the quality is the more important. By employing the environmental friendly economical process has always been challenged for the researcher. So nowadays the people is prepare the nanomaterial by difference, but you can concentrate one point. Your material or your synthesis is not affect the environment. Your synthesis is not very costly. It is and this is the very important is after preparing the material, it is useful for the particular type of the application. So then this point is very key factor to work in this field. So different technique for the nanomaterial, and this is always known everyone: hydrothermal synthesis, combustion synthesis, gas-phase method, microwave synthesis, Sol-Gel method, soluthermal method, chemical vapor deposition, thermal decomposition, and tempering. So all these methods are important. If you can search some, this is the all detail you can easily observe, but we'll discuss here also some of the technique. So design and degradation. So chemical products should be designed so that the end of their function, they break down and degradation product and do not persist in the environment. Real-time analysis of the pollutions, and again is the internally safer chemistry of the accidental prevention. So substance and the form of the substance used in the chemical process should be chosen to minimize the potential of the chemical accident, and including the relaxation, explosion, and fire. So many things is very important in this material. So all this thing is the base of the eco-friendly. Some of the very common synthesis are for preparation of the luminescence nanomaterial for different application, and these are, just you can see here, Sol-Gel method, wet chemical method, and novel synthesis, the combustion and Sol-Gel. So here is the Sol-Gel synthesis is completely for the nanomaterials, as combustion synthesis also prepare the nanomaterial, and you can change the fuel in the combustion method. So morphology of this particle, it is also changes, and in some time it is a completely nano form. So this method, just you can see co-precipitation method. This is some of the starting material you can dissolve in the water or any other solution, and then material is not the dissolved in the in this water or something. Then is the settle it down, and you can separate it. Second, it is the solid state diffusion. You can all starting material you can crush, diffuse at the high temperature. That is possible to prepare. Sol-Gel method is very typical and particularly used for the solid state synthesis, and very interesting. Combustion, it is also very interesting method. This is a very this material synthesis material prepare the high temperature, but actually temperature of the furnace is the very less. It means 550 degrees centigrade around, and this material prepare the 15 to 1600 degrees centigrade, but furnace is not required. So this is the very economical in terms of the energy. Wet chemical method is very simple method. Acid method, it is also very important. So just you can see that this is the solid state method. Just one of the example, you can prepare the AlPO4. So starting material aluminum oxide and ammonium dihydrogen phosphate in the particular stoichiometric ratio, you can mix it, crush for 1 hour, and again you can put in the furnace 500 degrees centigrade about 2 hours. So some of the water molecule is evaporated, then again it is cooled down, again you can crush, then diffusion process is properly, and fire at the high temperature for 24 hours. So this long time is the diffusion is proper, and this material is prepared. But in this method, nanomaterial is not possible. This is method only for the micron size or submicron size material. Wet chemical is important. This is the very easy, and it is not required any furnace. Only simple one is sufficient. Our heating plate is also sufficient. Just you can see here the material in the stoichiometric ratio dissolved in the double distilled water, and just you can other impurity again you can put, and is a critically heat from 60 to 80 degrees centigrade at a particular rate, then this material is prepared. In my laboratory, this is the Na2, SR2, L2, PO4, F6, F9. This is a very complicated compound also prepared by this method, and this result of this material is published as a high impact factor. Just you can see that this is the effect of the synthesis of method for photoluminescent property of the Na2, SR2, L2, PO4, Cl9. C3 plus nanophosphor is published at the 16.419 impact factor. And this is one of my students is the K. Shinde, myself, and one of my foreign collaborator, South Korean Professor K. Park. So this type of the work is possible. Today is the student demanding the postdoc fellowship. Today is the some of the teacher after joining the college is demanding the postdoc fellowship. But this CV is very strong. And this is the just to identify which type of the impact factor. So one impact factor is a normal for the chemistry and physics, but you can publish your work more than 4 or 5 impact factors, then it is called the outstanding research. So this paper is a 16.419 impact factor. So it is very important, and this is called the quality of the research. So combustion synthesis lead to the highly crystalline with the large surface area. The process involve a rapid heating of the solution contained in the redox group. During the combination, the temperature reaches approximately up to the 1600 degrees centigrade. Just to concentrate on the 1600 degrees centigrade for 1 or 2 minutes, or possibly is the 13 second only, and material is the crystalline. So this is the method. Just you can see here, all this material and just this flame. Flame temperature, it is the 1600 degrees centigrade, but actually this furnace temperature only was the 1500 degrees centigrade. So this material prepared at the high temperature, but furnace temperature requires less than. So this is the flame. So this flame only are possible the 13 second, and material is completely prepared in this case. And that is the final powder, it is possible. Again, just we want, so just you can see here, just this is the flame. So one of the compound SrMg2PO4 whole twice is prepared by the strontium nitrate, magnesium nitrate, ammonium dihydrogen phosphate in this method only for the nitrate starting material used in the nitrate form only. And then this material is prepared, and just by this process, and this is the temperature is at the 1600 degrees centigrade. Temperature of this flame is the 1600 degrees centigrade. So this material is possible. So just you can see here, this is the flame. Yeah. If this flame you can observe, then your material is 100% is prepared. So this type of the material is possible, and just you can crush it, then nanoparticle is possible here. So this soldier again is a very typical method. Just you can all this nitrate compound, and this is the again is the oxide. If you have the impurity, then you can dissolve in the HNO3, and it is a tetraethoxy orthosilicate you can dissolve, use in the distilled water. And completely still for the vigorously, and ammonia compound you can mill. Then again it's the same with the combustion method, and this is the compound is prepared by this technique. This is the soldier method, and green synthesis of the silver particle you can prepare. This is very important. Nowadays it is a very demandable. This is a very eco-friendly method. Any type of the plants. Some of the plants just work on this one. This is the aerocapsules and heterophysis, and this leaves, and some of the other leaves also you are used, and then you can crush it first, and according to this. So aqueous solution of this the silver nanoparticle, silver nitrate was prepared using by the double distilled water, and just you can crush all this leaves extract and any plant. So freshly prepared 0.05 mole silver nitrate solution in a conical flask, and the mixture heated continuously up to the 50 degrees centigrade for the 15 minutes. So this temperature is very less. So some of the lab it is not required the high temperature furnace. So they people is work in this method, and then it is possible it is a working at a very less temperature. And it is observed that the solution of mixture changes from the dark brown to brown, and the color changes of the mixture suggesting the formation of the silver nanoparticle. The synthesized nanoparticle centrifuge is the 1000 RPM. This is good for 10 minutes only, so that the nanoparticles were collected after removing the this is the solution in the outside. The collected nanoparticle where you put on the glass, and you can mix in the any organic compound is possible, very important. But you know the knowledge about this organic compound, diethyl glycol, to avoid the coagulation. Otherwise, this particle is mixed together and is converted in the nanoparticle. A similar process was used for the synthesis of the silver nanoparticle by the different type of the plant also. So this is the fresh leaves. You can crush it. Just you can heat and aqueous leaves. Then again converted into the silver nanoparticle, silver nitrate, and then again fire, and this nanoparticle is prepared. This is called the eco-friendly synthesis, and this is also green synthesis also. So this material is not much for use the chemical, only for use the This is the plants leaves, and this is the particular type of the material you can convert, and then this silver nanoparticle is possible. That this antimicrobial or antiviral activity is much more stronger. So nowadays in the pandemic season, this particle nanoparticles have so many applications. And this is the XRD pattern. So nanoparticle XRD is the very broad, and just you can see this material is prepared in the nanoscale, and just you observe the particle size less than to the 20 nanometer. This is the 10 transmission electron microscope. This is the images, and just you can see the nanoparticle form. And this paper is published. The result in materials, green synthesis of silver nanoparticle, and its impact factor is the 4.01. So this is the very important. So again, this nanoparticle used for again in the wastewater also. So this is also very important. You can use prepare the material and use the different type of the applications. So synthesis of the nanoparticles by vapor phase, liquid phase, and solid phase. So in the liquid phase, that microemulsion, this is important in the microbiology, hydrothermal, sol gel, sonochemical, microbial process, and solid state is the ball milling. But vapor work, the chemical condensation, arc discharge, hydrogen plasma, and laser pyrolysis. So all this is important. So this is the hydrothermal method. It is the one particular method that useful for this one. And similarly, the soluthermal method, it is a wide variety of the nanoparticle you can prepare, narrow size distribution, and particularly when the organic solvent with the high boiling point are chosen, the soluthermal method normally has better control of the size and shape distribution and the crystallinity than the hydrothermal method, and has been employed to synthesize the TiO2 nanoparticle and nanorod. So this TiO2 also important, this one. Chemical vapor deposition, again, it is a very simple CVD technique. The quality of the deposition material strongly depend on the reaction temperature, reaction rate, and concentration of the one. So in your synthesis, you can vary the temperature, you can vary the reaction rate, you can vary the concentration. So many type of the multiple combination possible, and then you can possibly the highly purity, highly performance material thin film is possible by this chemical vapor deposition. And thermal decomposition. This is also one of the technique. And this is the template. Just you can say the utilize this morphology property with the reactive deposition or dissolution. So this is very important. Construct the material with a similar morphology of the characterized material. And this method utilizes the morphological property with the reactive deposition or dissolution. So therefore, it is possible to prepare the numerous new materials with the regular and controlled morphology on the nano and micro scale by simply adjusting the nano morphology of the template material. So all these were important. Gas phase. It is also the physical vapor deposition technique like this one is possible. By this using the titanium oxide nanoparticle are prepared. So reduce the TiO2 powders in a necessary for the required conduction needed to the focus on the electron beam on the TiO2. So this is the very important for the TiO2 material. Microsynthesis, just you can use the micro at the home, but this scientific microwave, it is a completely, some gases is emitted in this one, then you can outlet is proper. So otherwise it is the gases also mix in this the chemical. So outlet is proper, you can control, and then you can prepare the very low energy. This material also prepared by the microwave, and it is required only for the 5 minutes. Just you can tea cup, you can put in the microwave at 120 seconds. This is prepared. Coffee is also prepared. So material is also prepared 5 minutes. Again, you can repeat. This is the process. Then you 5 to 10 minutes maximum. So this technique is also important, but it is not the homemade household micro. It is the scientific micro chamber. So this is the very important. Okay. Electro deposition technique. This is that required the high temperature. And spurting, it is also required the high temperature as well as to the spurt. This is the plasma is like this one is possible. Mostly use the spurting plasma like this one, and unlike the other vapor phase technique, there is no melting point of the sample. So this is the very important technique again, laser ablation. Nowadays the laser ablation is a complex process, and the maximum people is work in this one, but depend on the which application of this material. Then again, you can select this lithography, aerosol. It is a furnace method, flame method, all this type of the different method used for this one. Electro spinning, this is also very important, and then it is a totally free energy is possible here. So this technique is very important. I'm not going into the detail, and each technique also plays a minimum 10 to 15 minutes if you can discuss in the detail. Bottom to up one, it is a plasma thing, and this is the one of the plasma torch, and with help of this we can prepare some material. And solid thermal technique, the reaction occurring the solvent containing the sealed vessel while heating to their critical point under the this is the material, and then it is basically in the crystalline process, and that consists of the crystal nucleation and its growth. The particle morphology can be controlled by the tuning the temperature, pH, and reactant concentration. Again, this is the another technique. And this is the mass product. You can just prepare the material in the pilot form, and mass product is possible. So this type of the technique it is also used, and this is the batch system used for the large scale production of the nanomaterial. So it is possible, but in the last scale you can take the more precaution. It is not possible. You can just merge to each other like this one. So all these techniques are important. This is the microfluid reaction. This mechanical binding. This is a very important. Just you can apply the mechanical pressure on the solid one, then it is crushed in the fine particle. But during the crushing, number of defects generated in the fine particles. But this particle size is going to down in the nanoscale. That it is a very potential material, but in the same case you can find out this ball used in this mechanical mining. So this ball is not reactive to your material. So if you can use the particular type of ball or particular type of this material, so sometimes it is very costly material used for the balls, and it is not react to the material. So this is the highly pure nanomaterial material you can prepare by this method, but it is very costly depending on the cost of this ball and materials. So this is the very important metallic nanoparticles. This is the 1D, 2D, 3D, the different type of particles prepared. So the most widely used the metallic nanoparticle. A metallic nanoparticle means this is the particle with help of the metals in biological and biomedical application. Gold, silver, copper, iron, zinc oxide, titanium oxide, platinum, selenium, gadolinium, palladium, all these particles are very much important in the biological application. Mainly it is the microbial application like this one. So just that gold and silver, but copper is also most highly potential nanoparticle used in the biomedical application. But till that in India, no one concentrated on the copper nanoparticle used in the biomedical application. So just everyone is interested in the gold and silver nanoparticle. Just you can see so many advertisements on this TV. This is the silver nanoparticle on the paint also, on your teeth powder also, as cosmetic also. Then this is a very good reactive, and then eco-friendly. You can prepare by the eco-friendly that used in the cosmetic also. So you can change the method. You can reduce the cost, you can convert in the eco-friendly. So then the application is much more. And in the pandemic session, this is the gold, silver, copper, all these nanoparticles are very important. Again, is the zinc and titanium also. So it is not possible in this presentation, all type of the nanoparticle synthesis application, but little bit light on this nanoparticle will be discussed here. So if you can prepare this material in the nanoscale, though it is the characterization technique, is the XRD, it is a confirmation of the material is prepared or not. Second material paper is a confirmed by the only just look of this XRD, but it is not the confirmation. UV visible spectroscopy, that is the triple band. Field emission scanning electron microscope, the morphology. Again is the EDS, it is what is the composition, and photoluminescence spectroscopy, and according to the different type of the application, different characterization also is required. So it's so many applications that you can use the different type of the application also. So this is just the major categories of the nanomaterial. Just metallic, ceramic, semiconductor, organic. This is the another organic, silica, biological, and this is the again this is the biological matter. So it is very important for this purpose. So metallic nanoparticle used in the biomedical application, I'm already discussed: gold, silver, copper, platinum, palladium, platinum, selenium, gadolinium, titanium, zinc, and iron. So all these are very important. So application of nanoparticle now is the main part of this one. It is the nanoscience, nanotechnology application, the chemistry, biology, physics, engineering, material science, information technology, biotechnology, medicine. So that's why I'm calling this the interdisciplinary work. Suppose one chemistry people prepare the very good nanoparticle, but physics people is tried to, it is characterized by this one, and biological people is finding it is the antibacterial activity, and then is develop some device by engineering people, and then material science people is completely characterized, and then it is application by biotechnology in the particular medical application. So many field used in the, then this is called interdisciplinary work. You can develop some device and use in the information technology. You can prepare then this drug delivery, this is the medicine part. So all these subjects is work together, very important. So some of the new researcher, if you enter in the research field, just think in one mind, you always try to work your connect your topic with the other subject also. So therefore, I'm also working the different subject. Not a single subject I just left. All subject I'm working in the different subject: biology, botany, zoology, biotechnology, chemistry, physics, electronics, computer science, mechanical engineering. All these subjects are covered in my research. So just you can see this according to this is the totally work application, and this one. So this is a biological synthesis of the nanoparticle, and then its application. So biomedical application. Biomedical application, it is important. It is the good biocompatibility of this material. On the basis of it is the reactivity to the some germs. So synthesis of the biological material and form of the metallic nanoparticle exhibit the diverse optoelectronics property due to their reduce the size and shape. Another major advantage in the metallic nanoparticle, it is their the tunability. So this is a very important. And then the material can be synthesized by and modified with the various chemical function group, which allow them to the conjugate with the antibodies, ligands, and drugs of interest. So this is the gold nanoparticle. Of gold nanoparticle, what is the application? Just I'm going to directly targeted drug delivery, anti-cancer therapy, contrast agent in medical imaging, molecular imaging in living cell, antimicrobial activity, antibacterial activity, antiviral treatment, biosensor, intracellular analysis, photothermal therapy, hyperthermic effect of to treat the tumor, biocatalysis, biomarker. So if anyone is the consider one or two application of this material, then more than research for this. So particular type of the material you can prepare, you can fully characterize and find out your material for your application. What is your target? Target is the application of the material. If you are work with your antimicrobial activity, then you can find the antimicrobial activity. So then this paper is published as a high impact factor, then patent is possible and is directly affected the society also. So it is very useful for the society in the medical sciences. So this is the metallic nanoparticle. Maximum these are only for the some of the variation in the different nanoparticle, but this is the common application. This silver nanoparticle are bright yellow in color and typically showing the maximum absorption around the 420 nanometer. It is around the 420 nanometer. The property of the silver nanoparticle applicable to the particular type of the treatment still under the investigation for the assessing their potential efficacy, toxicity, and cost. So all these are very important. So these are the nanopart. Biomedical application also going to the same part, and this is the same thing. Just you can select the any type of the material and then application you can find in this like this one. So this is the some of the tissue engineering, implemented material, and antifungal treatment, antiviral activity, catalysis, dental properties, diagnosis application of devices. All these of the application are possible by this material. Copper is very important. I already discussed. Commonly available copper nanoparticle are typically 10 to 100 nanometers with specific surface area in the range of 5 to 70 meter square per inch. So copper nanoparticle is also available in the market, but it is not directly used in India. If directly you can concentrate on the copper nanoparticle, so this medical field is totally changes. So it is a very good biological activity of this material. So this is very important of the copper nanoparticle. So just the application in the optical function, catalysis function, thermal function, mechanical function, electrical function, magnetic function. So all this you can concentrate and work in this direction. And then it is possible that copper nanoparticle is a different application as a paint, copper nanoparticle as their catalysis application. Now this is the catalysis application, very important for the water purification, very important by using the catalysis function. There's so many applications of this one by using the photocatalysis like this one. So this is the biomedical application. The copper nanoparticle is observed mainly medical diagnosis, antibacterial, antifungal, molecular imaging, cancer therapy, photothermal ablation, and then the thermostic application and catalysis. So these are the main part of this application. Just like the zinc oxide also, similar different type of the application. So this is the topic is open for you. You can work in it. Carbon is no question. This is the fluorines, graphene sheet. It is very hard graphene sheet. So just you can work in this direction, 1 dimension, 2 dimension of this one you can work. Quantum dot is more important for this one. So then it is possible you can work in this one, and then different copper nanoparticles again like this one. So different nanoparticle in various size and shape is possible, and according to you can see. Just I have some of the example of the different shape and size of the nanoparticles. Silver nanoparticles. Just you can say in the particle size. This is the silver nanoparticle. Just I display only the particles. Just you see this is silver nanoparticle, less than to the 50 nanometer. Metal sulfide. Again, just you can see this is this type of the shape also. Just you can see that this is the CDS, MNS, and PBS nanoparticles. Just that this is the one of the reaction of the natural energy source light photocatalysis application for this one, and it is a detail in the photo decomposition of the 2 hydrogens. Just you can see this is the application. This is all topic is again is important to cover. It is not possible to cover in the one pair. Just the core shell like this one, nano rods like this, nano tape, cuboid, nano pentagonals, and again triangles, cubes, and nano rings also. Again, it is the sum of the nanoparticle in this form also, and some of the very conical. Then it is useful for the electron emission in the particular type of the device. So this is the very important. Just you can see this is the nanoparticle like this one. Just you can change the synthesis. You can prepare this type of the nanoparticle is possible. And according to this is the morphology. This is the different application. This is the marigold like the nanoparticle also possible. Just like a marigold. Just you can see this nanoparticle. I'm just display this one nanoparticle. So all this nanoparticle are prepared, different shape and size. So this is very important. At the top, this is the one hole. Then some of the material put in the hole. So this will play the important role again. So then this is possible. So according to the morphology of this nanoparticle, it is the just observe it is the application. Just you can see here. Just again this one. So all these nanoparticles are very good application in the different field, and just it is possible you can prepare this one. This is the quantum dot. Then it is the one. This is the quantum dot. It is a very specific application. It's very important. So low thermal expansion glass, mirror to satellites, microwave plates, bulletproof jacket, shield army for army, and then so with help of the nanoparticle, just you can convert it in the plate form. Then it is possible using the bulletproof. So it is the advantage is this is a very sturdy. It is not possible. It is strain is much more, and it is a weightless. So it is a very useful for the wearing this jacket as a bulletproof by using this nanoscience and nanotechnology. So it is a completely very important part of this one. Just you can see here is the different nanoparticle like this one. Zinc oxide nanoparticle, it is application, again, particle just like this one. The same image of the generally synthesized the nanoparticle. If particle size is less than 5 nanometer, then same is not possible. Only came is important. Some people is just 5 nanometer or 4 nanometer on the basis of the same. So this is not a good result. The particle size is less than 5 nanometer, then same is very important. Just you can see that this is the different particle size, and then you can measure in this one. So this is the vera leaf extract. So this is important. Iron oxide. Just you can see that this nanoparticle on this one. Green tea level. Calcium oxide nanoparticle. Serum oxide nanoparticle. This is important. This is the same image of the CO2 nanoparticle and select area electron depression. So how to take the picture of this? This is also very important. So zinc nanoparticle, it is prepared by this technique, and its application is a paint, antibacterial activities, slip cleaning, ceramic, and like this one. It is the sunscreen also. This is the again is the green positive and gram negative bacteria, and this is the different references also mentioned on here. So nanoparticle is the nano rods, nano tube, nano belt, nano spring, nano spiral, nano ring, nano wire. So this particle is also possible in a different form also. So all points are very important for the if you are working in this nano world. So this is the synthesis, one of the synthesis process. Again, this you can see here. So ZNO is the morphology of this in these pictures. TiO2, it is also very important in the optical study. And then optical material or display or any luminescence based material, TiO2 plays an important role. So this is the one of the method. I'm not going in the detail of this the TiO2, but this is a very highly potential material. If someone is working in this TiO2, then there's a very interesting topic remain. It is possible to work in these directions. So this is the again heat treatment of the FTO coated TiO2 before and after that. You can see heat is the drastically changes. So all this the preparation of the dye sensitized the solar cell. So this is solar cell you can prepare by this technique, and this is important to again. And this is systematic diagram of the dye sensitized the solar cell. Gold nanoparticle. Again, this is the simply prepare, and this is the gold nanosphere, hello gold nanosphere, gold nanoshell, gold nanorod, gold nano case, gold nano star, and gold nano cluster. So one material you can prepare in the different dimension, different things, then it is an application also different. So just you can see here, A figure, it is the nanosphere. Second is the hello and gold nanosphere. This is the C, it is the nano shell. Again, it is the D, it is nano rod, and nano star, and nano cases. So one material in the different form, then it is a different properties the changing. So if you can concentrate only for the one metallic nanoparticle, you can choose the different synthesis. You can prepare the different type of the nanoparticle. You can fully characterize and find out the application. So application 2 or 3 application, and you are an expert in this field. It's possible. So work hard in this field, nano field, by using the metallic nano, then it is possible in the much more biomedical application. So gold nanoparticle also one gold nano shell, gold nano rod, nano case, nano cluster, nano one, nano both, so are possible. So this is the very important of this material. Just you can see here. So this is the gold nanoparticle in the different shape and size. So it is the HRTM photograph. So this is the special facilities where that corresponding you can check it, and it is a very much Q at the central facility. So it is very difficult to get the same image within the week or within the month also. 3 or 4 months waiting in every one places, and this instrument is very much cost 3 crore to 5 crores. So then it is possible. If you have the facility, you can work easily, and you can show that it is the dimension is much more. Any type of the nanoparticle. So now, after this, the nanoparticle, nanosynthesis, its application, and all these things, I'm concentrated. If you can work very hard, so which type of the instrument is possible? Just myself. My research topic is the lamp phosphor, TLD, thermoluminescent dosimetric phosphor for radiation dose measurement. I'm working phosphor, supercapacitor, solar cell, luminescence instrument, phototherapy, for the treatment of the skin, water purification, and fly ash utilization. If anybody interested to work in collaboration in this field, so I'm always is ready, and my lab door is always open. I'm interested in the very collaborative work. I'm not concentrating only for the physics. I'm not concentrating only for the synthesis. I'm also concentrating how to convert my material in the product form. And then my student is much more benefited. So in this, due to this, my 10 students presently get the postdoc fellowship in the abroad. And presently 3 or 4 students in the present, one in the Taiwan, one in the South Africa, one in the Sweden. So this is the possibility. If you can work, students are working in high quality paper, then postdoc fellowship is also possible. This is one of my paper is published in the Progress in Material Science. With my one student present in the South Africa, one my foreign collaborator and myself, its impact factor is the 39.58. So this is the important. You can publish the paper always in the Scopus indexing, and impact factor is the Thomson-Rutan impact factor. Don't use the open access. I have published the 600, presently the 88 paper on the Scopus, 688. And some of the paper is the non-Scopus indexing, but till date I'm not publish any paper by single rupees. I will not pay. So this is the 39.58 impact factor. This is the just we know that the nanoparticle is prepared. This paper is 16.419. This is a renewable and sustainable energy. Review article is very important. If you have some problem in the experimental or some student is very busy, is not get the chemical or some problem, so please you can motivate the
Participants, there is some technical issue, so kindly wait.
Sandhya sir, kindly unmute yourself.
what is the problem with my top?
Yeah.
Well, just wait 1 minute.
You are audible, sir.
Yeah, but my screen is not display. Na? I will try to my screen display for my screen also.
Sir,
I know that.
It's visible.
It's visible.
Yeah, screen is visible.
Yeah.
Yes.
Screen is visible. But I'm not observing my screen. So please, I will try to. 1 minute, please. I just only few parts is there. Slide number 123. Right, please. Provide my screen. Screen. 1 minute. Huh?
The screen is visible.
But मुझे नहीं दिख रही ना. मुझे नहीं दिख रही ना screen. Screen आ गई. It is visible for me. Now it is visible, madam.
Yes, sir, it's visible. आप बस थोड़ा हाँ, it's visible, sir. It's full screen now.
Okay, thank you. Okay. So now this is my one of the nature paper. Now it is another paper in the Journal of Luminescence. Just you can see this is a prediction of the excitation wavelength of phosphor by using the machine learning. Then this is in collaboration with the computer science department. So it is the impact factor of the 3.55 Journal of Luminescence. And now it is I'm also working on the carbon particle for the biomedical application with the Viva Chopra. So this is a very good collaboration in the DAV college with Viva Chopra. And then I'm using the different ion beam and prepare the different material. And this is the impact factor is 2.478. Again, this is another paper. This student, my Karan Kumar Gupta, presently working in Taiwan as a postdoc fellow. And this is the paper is the 3.43 in the physics, chemistry, chemical physics. So all this type of the subject. So just you can see the important. You can publish your paper only for the Thomson total impact factor, and just the scope percentage. Other paper you don't try to publish, and it is not much more expenditure. So this is my record. One paper is the 39.58, 12 paper in the 10 to 20 impact factor, 5 to 10 impact factor, 25 paper, 4 to 5 impact factor, 49 paper, 3 to 4 impact factor is a 143 paper. Again, it is a 2 to 3 impact factor, 222 paper, 1 to 2 impact factor, 108. Total paper is 889. But some of the paper, it is the Scopus indexing, but it is not the till date gets a impact factor. But some is the paper, it is the without Scopus indexing also. But out of this, total paper is published in the Scopus is the 688 now presently. So total paper is 889. Without Scopus is with Scopus indexing 621, and without Scopus indexing the 268. So just you can see the progress in the material science. The one paper, renewable is the 9 paper, is the 14.5. Nanomicro is the 16.1 paper, and NPJ 2D it is the again the 1 paper. In this nature group, critical review is a 10 impact factor 1. Again, just you can see this is the different impact factor and number of paper. Just here, journal of allied compound is the 16 paper is there. Journal of allied and compound it is the 16 paper, and then again just you can find again here journal of allied and compounds is the next one again. This is Ceramic International 4.5 is the 11th paper, and this is the 5 Journal of Allied Compound, and 5-6 Progress in Solid State 1 paper, and this is Journal of Luminescence 3.599. It is a 78 paper, and this is a Luminescence, the Journal of Biological and Chemical Luminescence 2.46, 118 paper published in the one place. Optic, it is the impact factor 2.443. It is the 57 paper. So this is the important book publication is the 21, edited book is 12, and chapter are published is the 39. And I'm also editor of this one, the Luminescence, the Journal of Biological Chemical John Valley. It is impact factor 2.464. I'm also visiting professor in the Sejong University in the South Korea. So total paper it is the 8089, and paper published on the Scopus 684. Yesterday my paper is the 677. My record with the Viva only for the 677, but yesterday published the 7 paper on Scopus. So now is the presently 684. Just you can go the scopus.com. Just you can enter my name Doble, initial name the HJ, and RTM Nagpur University. You can get my report. And this is the data. 684 paper in the Scopus. This is the Scopus data. Scopus data on 15 July. Citation is 7214. H index 35, and this is the bar in the number of paper in the each year. This year my paper are published in the 57, and my citation is the 7214, and H index is the 35. How many paper in the each year? I'm just in the one table. 13 is the 53, 14 is the 65, 15 is the 60, 16 is the 54, 17 is the 55, 18 is the 56, 19 is the 40, and 20 is the 59. And this year up to July, today, 15 July, 57 paper in the 2021 on Scopus. And this is the indicate with help of this graph. Just this graph is totally indicated like this one. So my citation in the Google Scholar 9,159, HLS 40, I-10 index 270, and this is my Google Scholar record. Just you can see here. This is the all these things possible. One paper is the 577 citation also. So total paper, just you can see the in Scopus, the LAM FASPA 172, 132 paper. I'm in the top position in the world on the basis of the Scopus records, and total paper on the TLD 89 paper. I'm also top position in the world on the basis of Scopus, and total paper published on the FASPA only 545 paper. So here also I'm the top position in the world. So FASPA, TLD material or LAM FASPA, I'm in the top in the world on the basis of the Scopus data. Total my patent is 41, granted are 9. 1 in the South Korea, 6 in the Australia, and 2 in the Indian. Published 31, and 1 patent is a 5. I am also the in the month of July, means my 4 patent accepted in 1 month by Australian, and it is completely granted. So this is the current news. And this news in the today in one of the Marathi paper is the Tarun Bharat. So I'm not displaying here. This is my Honorable Vice Chancellor. This is a Pro Vice Chancellor. This is the Registrar. This is the IL Director. This is myself. And this is my research team. She's my wife. She's also professor in chemistry. This is my student. And in this team is the Vibha Chopra is also there. Just you can see her name here. This is the Dr. Vibha Chopra. So 1 patent with the Vibha Chopra, Australian patent, published with her also. So my work is always collaborate with the other people and just get something new. So this is hardworking. It is the my style. I'm also 2% scientist in the world on the basis of the Scopus data, and this is the Stanford University. I'm one of the person in the Center India in the 2% scientists in the physics. This is my 65 students are getting the PhD. Here list up to the 56. The list is not time for the ad, but it is 65 students get the PhD and 8 are working. I'm the editor of this one. Just my name, just you can see here. And this is Indian flag, just mentioned here. So just I'm editor of this. I'm very happy only for the all countries. I'm one of the person with my Indian flag. So I'm very happy. Its impact factor is a 2.464. And I've visited Italy, Egypt, Greece 3 times, Australia, China, South Africa 2 times, South Korea, Japan, Sweden, Malaysia, Hong Kong, England, with for the research work. And visiting scientists also, and some of the time we stay the long time for the research also. I'm also much more interested to publish the book, author book, as well as to the reference book. This is one of the book published by the Elsevier, Principle and Application of the Organic Light Emitting Diode, with one of the colleague, Teju Kalyani, and my foreign author, a collaborator, S.S. Swart, and myself. So all these 3 are here. And this book is the first book of my university, published by university authors. So this book released by the Vice Chancellor in that time, Pro Vice Chancellor, Dean of Science Faculty, Registrar, and this is the Director of the National Institute of Technology, myself, and my collaborators. So this press also encourage this type of the people. And then our group and our well-wisher are very happy. Okay, you are doing the very good work. So this is the news also. Another nanomaterial book also published, and this is one of the editor of this, and this is the publishing there. This is the Elsevier symbol. This is the Elsevier symbol. And this book also released by the Vice Chancellor and all higher authority of the university. Nanomaterial for the green energy. So this is my nature to work very hard. This book with the Vibha, just her name is Vibha Chopra. This book released on the 14th February 2020 in the international conference at my place, Nagpur, and Vibha was also present on this occasion. And just you can see this is Vibha. And this is again Vice Chancellor, Vice Chancellor, Dean, and this is the Luminescence Society of India Chairman. It is the KVR Murthy. This is very important. And this is the one myself, another author, and this is Vibha. It is also author. Only for Swat is not present here, but this is the published at my place. And I'm very happy Vibha also present in this occasion. And some of the felicitation by the Vice Chancellor. This is my Malaysian collaborator. This one book I accepted in that time, and also felicitate our Vice Chancellor in that occasion also. So this is the new book is again going with the Govind Nair, is the fundamental and application of light emitting diode. This is a very interesting book in the. He's my student, Govind Nair. and now present in the South Africa as a postdoc fellow. This is an author book by Elsewhere. And he's the chairman of the society. This is my foreign collaborator, and this is myself. Another book is published in the Springer also, phosphate, phosphorus lighting. And just you can see the Amazon, all books are possible here. So all this, some of the books in my chapter in the different publications. So all these books published. This is my one student presently in the Uttarakhand for NIT, but he postdoc from this under this SWAT. And this myself released one book in the South Africa. So this going also. This is our ex HRD minister, but that time is HRD minister, and he's select on the basis of the Scopus data. I'm just select for the top 10 physicists, but I'm in the second position in the top physics scientists in India. So in that time, this is the AICT director, Sahasra Buddha. This give me the top faculty awards. So this is a very good for me. So one of this chairman of this AICT honored me by this top faculty award in the physics in the Tin Murti Bhavan. So Professor Doble honored with the India top faculty research award, and this award received the Tin Murti Bhavan, New Delhi. So this is all this type of this news is very important for my students, for my university. So this university is possible a very good ranking. This is the Lifetime Achievement Award, and some of the felicitation in some of this Marathi news you don't know, but these are domain research paper, high impact factor. 1 mark paper is 39.5. I'm also received the Vidarbha Ratna Puraskar. This is I'm staying in the Nagpur, in the part of the Vidarbha in Maharashtra. So Vidarbha Ratna Puraskar also, and this is the again and this is the number of visits in the different place, and this is my all collaborator in the lockdown time. Developed some of the UEC basis unit, and 8 patents are published on the UEC net with the different this pharmacy people, chemical chemistry people, and the Vibha Chopra also developed the mobile unit and PP kit sanitization unit, and again what. So 3 units published by with Vibha Chopra. And she's my wife. This is also working, but the people are microbiology people, some of the pharmacy people also. This is my international collaboration. Already, so my students easily get the postdoc fellow in this foreign country, and very good help to international people to my research. So this is my room. I'm sitting now presently in this room, and this is the all papers for the NAC display, and this is myself. This is my research team. Without research scholar or collaborator, research is not possible. So you can develop your relation with the student. You can develop your relation with the collaborator, and then it is possible. And at a time, I handle all this stuff of the research student. Some of the PhD holder also, but presently working with me. So thanks to all my research student and research collaborator, my lab is open for collaboration. So this is my mail ID, and this is my mobile number. Anyone is contact, then I'm always ready for collaboration. So thank you. Principal Sir of DIV University, head of the department, all team of this FDP, and special thank to the Vibha Chopra. She is inviting me for this occasion. Thank you very much. Vibha, thank you, and I might hand over to you.
Thank you so much, sir. Thank you so much for the enlightening lecture, sir. Sir, you have really took us to the world of nanoscience. It was really enjoyable as well as knowledgeable and beautifully explained lecture, sir. And we are really overwhelmed to see your last slide, especially for your research and your collaborations, your research papers. And I must mention that being your collaborator is a power in itself. So one really feel powerful being your collaborator or your student, and associating with you is a power. So thank you so much, sir, for everything.
Thank you. Welcome.
And sir, you beautifully explained starting from the basics to the research of nano. It was an awesome journey with you. Thank you once again for being with us, sir. And
Thank you,
one
ma'am.
of our participant, Dr. Dinesh Kumar from Arya Degree College, Nurpur, Himachal Pradesh, also says it was an excellent talk, sir. So we have few queries. So I want to just read those. Dr. Maninder Kaur from DAV College, Amritsar, she want to ask, sir, which one is best for the targeted medicine delivery and cancer therapy? Is it gold, silver, or copper nanoparticle?
Maximum is the silver nanoparticle useful for this, but the reactivity of the gold, silver, and copper, some of the variation, but totally depending on the synthesis of this nanoparticle. Synthesis of the nanoparticle is the changes that correspond to the reactivity. It is also completely vary. So you can concentrate on the synthesis. How to it is the characteristic is show is the reactivity. And you can give them my email ID. Some of the interested, then you can mail me. I will reply any queries.
Thank you, sir. Dr. Manpreet Kaur from DAV College, Amritsar wants to ask how to control time and temperature simultaneously while preparing nanomaterials.
This is a very critical role for the preparation of this nanomaterial. Simultaneously, you can maintain the time as well as to the temperature. It is possible to the your experience. And then you can prepare the material, and some of the your target is not finally in the nanomaterial size, so you can vary the temperature as well as to the timing also. So after that you can optimize particular, and then you can say this temperature at this time is the best for the preparation of this particle, and is the morphology is this much. Simple way is the combustion technique. You can prepare the nanomaterial, but you can change the fuel that corresponds the morphology of the material is completely varied. So many type of the factor is possible to hear.
Okay, thank you, sir. Dr. Vishal Arora from Hindu College, he wants to ask if ball milling is the best method to get the purest form of the nanomaterial, then why we do other methods that are not economical?
The ball milling, it is a totally depend on the quality of the ball. If your material, starting material, very reactive, and this ball is reaction with this, so it is not the up to the level. So if you can choose the select the high quality of the ball, and it is not react your material, but it is cost is very high. So it is not possible to everyone lab. This is the highly high cost material synthesis apparatus in particular lab. Then funding is the main problem. Only for the some of the project, and just to the project more than 30 lakh, then another type of the committee. So your CV is good, then it is possible. Our college, it is not good so much for fund. So many problems. Or some collaborator is there, or some is the you can work in the another lab. So it is very difficult to permit this one. So just you can try to the different type of the synthesis, and which one is the best for you and your availability of the device. So you can select this one.
Okay, thank you, sir. Now, one last question is from Dr. Jagdish Kaur. What is the difference between SEM and TEM readings for nanoparticles, sir? Which one is better?
Same, if particle size in the 40 to 60 nanometer, 30 nanometer, same is okay. But particle size is the less than to the 5 nanometer, that only TEM is the confirmation. You cannot imagine for the same, this is a particle size of 2 nanometer by same technique. So scanning electron microscope, this is one of the technique for the nanoscale, but quantum dot only possible for the TEM technique. Okay. So this is the very important difference.
Right, right.
Okay, thank you.
Thank you so much, sir. We are over with the queries also, and it was really awesome to be with you and listen to you, sir. And thank you once again for accepting our invitation and being with us.
Thank you.
Thank you so much, sir.
Thank you, madam. Thank you, madam.
Now for the participants, we will be shortly starting with our next technical session, that is from Dr. Bindya Arora, and Dr. Maninder Kaur will be the coordinator of the session. And you please, all the participants are requested to wait for a few minutes so that immediately. Okay. Our speaker has joined. So Now I hand over to Dr. Maninder Kaur for the next technical session. Over to you, ma'am.
Good afternoon, everyone. So I welcome Dr. Bindya Arora. She has joined us. Ma'am, we welcome you in this session. Ma'am, please make ma'am host. Ma'am, we are making you host right now. So till then, I would like to introduce Bindya ma'am to you. And as already in the morning, sir has stated that she's the favorite of students, and it's my good luck that I have been her student for my PhD degree. And she was a wonderful guide and a dear friend. So, ma'am, my heartily welcomes to you, ma'am, with us. So for a formal introduction, ma'am is having a glorious achievements throughout her academic as well as professional career. Ma'am has done her graduation and post-graduation from Punjab University, Chandigarh, and she grabbed a gold medal for her graduation. Then ma'am did her PhD degree from the University of Delaware, USA. Presently, ma'am is working as assistant professor at Guru Nanak Dev University, Amritsar. Ma'am is very active in her research, and it's her dream actually to be that is awarded with the most prestigious scientist. I always wish her all the best for these thoughts. Her research interests include theoretical atomic physics, and the research work includes study of optical and atomic frequency standards, optical trapping of atoms and ions, study of ultra-cold atoms, study of long-range interactions, development of high precision methodologies for the calculation of atomic properties and applications of such calculations. MAM is also a part of a portal for high precision atomic data and computation. And this portal has been developed in collaboration with the researchers at the University of Delaware. This portal is an open access, and it provides various atomic properties for a number of atomic species. MAM has authored almost 34 peer-reviewed papers in journals of very high repute, and MAM has guided 4 PhD students and 25 master theses. Ma'am has delivered almost 40 talks in various national and international conferences, workshops, and seminars. Ma'am is having many awards and honors to her credit, she has been awarded Young Women Scientist Award by Pearl Foundation recently in 2021. And I'm so happy that she was selected among the top 3 women scientists of India by Nasi Scoopers in 2019. She was selected for INSA DFG Exchange of Scientists program to visit our university in Germany. I'm not pronouncing the name, ma'am, because it's a very complicated name. And she was nominated for INSA Young Scientist Award. And list is still too long. And she's getting too many research grants also. So, ma'am, we are lucky to have you with us today. And today's lecture is going to be wonderful for all of us, as ma'am will be teaching us how to write papers in LaTeX. And as you all know that LaTeX, it is the that is platform to write the papers which are published in journals of high repute. For example, mostly what we do, we that is write our documents in Windows using the Word files, Word application, and we save it as a doc or docs file. But the problem over there is that we have to do many adjustments manually. For example, we have to keep the spaces intact manually and all that. But here in LaTeX, everything is so organized that we are not to do such sort of manual things over here. So for the best, ma'am will continue will start with this lecture and will tell us from the basics till what the time permits us. So, ma'am, over to you now.
Okay, thank you, Maninder ma'am. Thanks a lot. I'm overwhelmed with the kind introduction which you have given to me, and I congratulate PG Department of Physics, DAV College, Amritsar, for organizing this faculty development program on recent developments in physical sciences. I'm thankful to the principal sir, Dr. Rajesh Kumar, and head of the department, Dr. Sameer Kalia, and obviously to you and Dr. Vibha for inviting me as one of the resource persons. So I hope I'm audible and my voice is clear.
Yes, ma'am, you are audible. Screen is also visible, ma'am.
Okay, so I will start sharing my screen. Okay, so I hope my screen is visible to everyone now.
Ma'am, screen is visible.
Okay, so I'll talk about LaTeX, which is one of the editing softwares. I'd like to call it a programming language, mostly because it involves some commands and kind of algorithm which we usually use for programming language. So it depends on what kind of definition you want to use for LaTeX. What I intend to do is I intend to do a training program for the participants of this faculty development program. So I'll start with a very small introduction to LaTeX, and the training program will involve a couple of exercises where I'll share my screen, show the commands, various commands which are useful in LaTeX. And I request all the participants to simultaneously do those on their systems if they have. If they don't have a system and they are using a mobile to attend this, then they can just listen to the talk, and I hope they can try it later. So I'll start with briefly describing what we intend to do during these two sessions, today and tomorrow afternoon. This is the presentation outline. We are going to discuss about the pros and cons of LaTeX and how LaTeX evolved from tech, how we work with the basics of LaTeX, and what are the various components involved in it. So the learning goals would be to be familiar with what is LaTeX, do a couple of assignments and exercise, because in 3 hours of stipulated time, I don't think we would be able to have a very good hand on LaTeX, not a very professional hand on LaTeX, but still we are going to try to get us familiarized with how to start at least. So once you have started with something, I think carrying it on is always easier. Something to start is always a difficult task to do. So there are roughly 5 blocks in LaTeX. One is the basic block, basic commands, how to write it, how to start a document, then how to edit the text, how to write mathematical expressions, equations in LaTeX, how to handle tables and figures, how to handle references or bibliography, how to make presentations, for example, presentations for PhD scholars, how to make these PhD presentations or presentations during conference. And obviously, there are numerous more blocks like how to write thesis or how to write books, articles, etc. Obviously, we won't be able to cover all, but what I'm going to try to do is I'll try to go through the basics, give a flavor of how to write text, how to handle text and mathematics in LaTeX, and just a little touch of tables and figures. This I'm not sure if we'll be able to cover or not. And obviously the other 2 parts would be very difficult to cover in these 3 hours of time. So what is LaTeX good for? So all those softwares like Windows editors or tech editors, notepads, they are what you see, what you get kind of software. So what you see is exactly what you get. LaTeX is a different kind of you can say program which has a logical design to it. And basic differences between LaTeX and other editors which we have been using to write our articles or papers or thesis are, for example, writing mathematics in LaTeX is very, very convenient. It looks beautiful. It does not involve use of mouse. Whenever you are using mouses, the speed of writing decreases. Using keyboard always speed up writing your documentation. So writing mathematics is very, very simple in LaTeX once you get familiarized with the commands. Obviously, it looks beautiful. There's a definite difference between the output from a LaTeX document and a Word document. And you can clearly say that this is a document which has been produced using LaTeX. Bibliography is very, very convenient in LaTeX. We use BibTeX, which makes our life easier in order to cite these references, ordering these references, etc., which is not so convenient in Word. In Word, you have to usually worry about the order in which you are putting the references. So, for example, if you have put your reference, if you have two paragraphs, the first paragraph has reference 1 and 2, and the second paragraph includes reference 3 and 4. And during the course of editing, you decide to move the second paragraph on up. You have to manually change the order of the references in Word, unless you're using paid softwares like EndNote, etc. So that is a different thing. But in Word itself, you have to worry about ordering these and citing these references. In LaTeX, you don't have to worry about it. It's a programming language, so it automatically reorders all the references. It's very convenient to use. Third, very important advantage of using references of LaTeX is that it is platform independent. Platform independent means that LaTeX, even if you use on a Windows system, on a Mac system, on a Linux or Unix based system, or whatever version of Windows you are using, your outlook of the document will not change. However, this is not seen when you're using Word. Word on your system would look different as compared to a system on which a different version of Word is installed. So it is not platform independence. It depends on what kind of operating system you are using, what version of Windows you are using, or what version of Microsoft Word you are using. See, while writing, this is something which I'll say is kind of disadvantage of using LaTeX. In Word, what you type is what you get. But since LaTeX is a programming kind of editor, what you write is a program, you have to compile it, and then you get a output in a DVI or a PDF form. So what you're typing is not exactly what you are going to see in your output. And another very good advantage of using LaTeX is that you can make your own commands. You can define your own commands, your own functions to make your life easier. So for example, in Word, if you have to type one symbol repeatedly, you have to copy paste it. But in here, what you can do is you can define a very simple command for a very long equation. And if you want to use that equation repeatedly, you just type that defined command in short form, and then you can easily use it multiple times. So all these things will be more clear when we are going to do some exercises. But when I compare LaTeX with the conventional word processors like Word, Microsoft Word, etc., what I like mostly about is the quality of the output which I get using LaTeX, and ease of including mathematical formulas, which is very convenient. And obviously the bibliography. This is the major advantage of using LaTeX, how it handles bibliography. Source file in LaTeX is not, as I said, is not bound to the operating system or the platform or the computer system which you are using. LaTeX looks similar, works similar in all kind of versions and all kind of operating system, be it a DOS system, Windows, Unix, Linux, Macintosh, etc. It is free. You don't have to purchase it like Windows Word. Now it is a de facto standard for various scientific publications. So if you have the knowledge of LaTeX and you are writing your paper in LaTeX, it definitely puts a much stronger impact on editors and referees as compared to submitting documents in Word. I'm not saying that using Word says that the quality of research work you are doing is substandard, but definitely learning something new is always an advantage. Handling bugs is much easier in LaTeX. Obviously, there are no bugs in Word, so that is an advantage of using Word. It is very good for large documents, especially which involves number of figures, number of references, which are very hard to handle in LaTeX. It can run, this is again the same point, that it is not dependent on any operating system or platform. So it can also work on the microprocessors which were introduced in 1985. But Word will not work. Word depends on the version of the system which you are using, or version of the Microsoft installed on your system. The only disadvantage is that it is not easy to learn. It is not easy to learn to start, I would say. Once you start to use it, you get so comfortable and you see so many advantages of LaTeX that you never try to go back to using Word. So it is just the glitch of using it, starting to use it. Once you start it, you are very comfortable with using LaTeX. Some drawbacks are that in LaTeX, there are moving parts. You have very less control over tables and tables and figures. This is one of the disadvantage of LaTeX. In Word, if you put a table or a figure at some point, at some place, it is fixed at that place. It does not float. It does not move on its own. But LaTeX does not give that advantage, I would say. It is sometimes difficult to remember commands, although commands are very easy, simple. And nowadays, Google engine works much easier. So I won't say it is a very major drawback. Preview delays are there. So obviously it is not what you type, what you get kind of software. So you have to write and then compile and then see how your output is going to look like. There might be some syntax errors since it is a programming language. You have to fix those errors. And adding new fonts is always cumbersome, which is not so cumbersome in Word. But in spite of all these drawbacks, the advantages are so much that I always prefer using LaTeX over the conventional Word or other editors. Coming to the evolution of LaTeX, it actually evolved from something called TeX, which was written by Donald Knuth. And this is a very powerful programming language, which is more complicated than using LaTeX. A simpler version of LaTeX was built after TeX, and LaTeX is actually a micro package of TeX, which is much easier to use. So people who use TeX are more professional and more, they have more knowledge of these commands. So LaTeX is much simpler than using TeX. There are two versions of LaTeX at present. One is absolute. The currently used version is LaTeX 2 Epsilon, and Epsilon obviously means that the difference between both the versions is not major. And if you're still sticking to the old version, you can use it. There won't be any major differences. The commands are basically same in both the versions. And then MikTeX is a distributor of LaTeX. And the distributor is open for Windows, Linux, and Mac systems as well. But the way LaTeX thinks is in boxes. It does not type characters. It types boxes actually. So whenever I'm typing, this presentation has been prepared using LaTeX. So this character L or this bullet 1 is all in boxes. If you are inserting a figure, it is always in a box. So LaTeX is not, we can say it does not think in terms of characters, it thinks in terms of boxes. So this is a fundamental, you can say, concept of LaTeX, that it thinks in boxes, it prints boxes. So for LaTeX, this L is a box, not a character. It has allotted a space to this letter L. The way LaTeX works, it produces number of files with various extensions, not unlike a document file which has a .doc file, single file, which is your output file. It produces number of output files when you try to run it. One is the TEX extension file, which is the source file, the file where you are typing your document. One is STY file, which has all the LaTeX packages which you are using within your text and other style files. BST is for the style packages for the bibliography, because if you have noticed in various journals, the style of bibliography is different. So what style you want to use is stored in this BST file. Log file is a temporary, people who are familiar with programming language, they know that log file, it includes, it's a temporary file which includes all the errors while you are compiling. AUX is a temporary file. AUX, BLG, they basically are similar. They are a temporary file which handle the references which we are using. TOC is the temporary file of table of contents. LOF and LOT are similarly temporary files which handle list of figures in your documents and list of tables in your documents. Then BIB file is a bibliography file where your all the references, you have put your all the references is the bib file. So you can, there are two ways of putting references. You can put your references within the text file, or you can make a separate bib file for your references. And then the output is in the form of DVI or PS or PDF. The most important files which you should not be removing are the text file and the bib file. All other files, they automatically are produced when you run text file. So when you run or compile your text file, all these files are automatically produced. So what you have to be careful is that you do not delete text and bib file, because these are the files which you have to generate, which you have to make. Other files, the system is going to produce on their own. This is the document structure which we are going to also practice on LaTeX. First is the preamble, the starting part of your document, which includes the document class, which states like what kind of document it is. Is it a book, or is it an article, or is it a presentation, etc. So this document class contains that information. Then what kind of packages you want to use? Do you want to include text which is in color, or you want to include figures? So depending on what you want to do in your LaTeX documents, you have to include those packages which support that kind of work. Then is the front matter. So after you're defining what kind of document you are producing in preamble, the front matter tells you the title, the author, the affiliation, etc., and abstract. Then is the main body, which contains the main content of your document. And in the end, you have the bibliography. So this is the basic structure of your LaTeX document. In preamble, as I said, you include document class, what kind of article it is. This is the command which every LaTeX document is started with. So / document class. So this / actually marks that this is a command. So this point I'll cover when we are going to do some kind of exercise. So this / has a very important role. It defines a command. Then what kind of package you are using. So you are using colored package, etc. This is the second step in your preamble. These are very commonly used document class, as I said, article, book type, report, etc. Then in the front matter is your begin document, which ends with a end document command. And within begin document and end document, this is your front matter, which is what is the title of your article, who's the author, make title, all these quantities are made, title, abstract, and if you want to break a page, start with a new page, and so on. So this is the front matter. In the body, you have to type your contents, and mostly you divide your body into sections, subsections, or subsections, and so on. And if you don't want to number your sections, like section A, section 1, 2, 3, and so on, you can always use a star sign. So in this way, there will be no automatic numbering of the section. Then there are a number of commands to format your text. Like if you want to bold face your text, if you want to color it, you want to underline it, you want to use subscript or superscript, etc. So all these things we are going to cover in a training session. Then in the end, after your main document is the bibliography. And there are very convenient ways of managing these bibliography. One is JabRef, which I'm not going to cover. It is something similar to EndNote, I would say, but this is free, unlike EndNote. And there are various ways to make this bibliography. As I said, either you can include your references within the tech document, or you can make a separate bib file of your references. There are various variants you can use for LaTeX document. Some people use Kyle or Text Studio. So these are the editors for your LaTeX document. So for example, for a Word document, you use Windows editor. For LaTeX document, you can use any one of these editors. All these editors are freely available. You don't have to buy them. Since all these editors, they require installation, which is itself a time consuming thing. What we are going to do now is we are going to practice some of the commands, LaTeX commands, and how to start with writing a document in LaTeX. We are going to use an online editor, Overleaf. And if you have your systems ready, we can always try all those commands in Overleaf. It is a very convenient online editor, especially if you are writing papers in collaboration. So if I am writing a paper in collaboration with some of my collaborators, I can always share that document with my collaborator, and we can both simultaneously make editings in that document. So it's a very nice editor. So with this, I would like to end this talk. I'm sure you have a lot of queries, which I hope will be answered when we do the training session. But still, if you have some specific questions, I would like to take them now before starting the training session.
Ma'am, there are no queries yet.
Okay. So, Maninder ma'am, do the participants, they have some access to the some kind of working like desktop or laptop?
Yes, ma'am, they may be having.
Okay. So those who don't have, they can just try these commands later. But for now, I would like to start with the assignment.
Okay, ma'am.
So for those who have a system ready with them, they can open Internet Explorer and type Overleaf. overleaf.com. You do that.
Excuse me, ma'am. Can you please make one thing clear?
Yes.
We are having Windows with us, so
it will work on everything.
It will work on. Will it
Yes,
make
yes.
any effect?
No, this is an online editor. It is like using a website.
Okay, right. Thank you.
So it won't matter. That is why I didn't opt for a installation process, because it is very time consuming. People have Windows or Linux or Mac system. So it's different for different systems. But the website which I've shown, overleaf.com, it will work similar on all the operating systems. So
it will make no effect on the system, and moreover, we can use online this.
Yes, without installing LaTeX. You don't have to install LaTeX.
Okay, right. Thank you.
This is a so overleaf.com. You will get a login page. Either you can log in, register on Overleaf. I prefer to use it using my Gmail account. So if you click on login with Google, yeah, it will ask you to log in using your Gmail account. So these are my previous projects actually, which are in collaboration with different collaborators. And see, if you see here, the collaborators, they can simultaneously edit these documents.
Excuse me, ma'am.
Hanji, ma'am.
Ma'am, are you sharing your screen?
Hanji, oh, it's not shared. I'm so sorry.
Oh, yes.
Sorry. Let me redo everything then. Let me log out. And I didn't realize I was not sharing. So if you type overleaf.com on Internet Explorer or any other internet, these, what do you call these editors. So a page like this is going to open. Click on login. It will ask you to either register your email or you can log in with Google. So I prefer logging it with Google, my Gmail account. Select my Gmail account which I want to use. And these are my previous documents, LaTeX documents which I have written and shared it with my collaborators here. So different collaborators have simultaneously worked on these documents. You can start with a new project. I'll start with a blank project. But if you see here, you have different options. You can either start using a template for a journal or a book or a poster or a presentation. So already these available templates are there, and then you can make changes there. But let us start with a blank project. I would name it. So this blank project has started. If I now click on it,
Excuse me, ma'am.
Thank
Few
you,
of
ma'am.
us are not able to register. It's showing its password incorrect or something because no,
Okay.
and it's showing not registered already.
Yeah, because you have to register. So don't register. I hope you all have your Gmail accounts.
Yes, I'm clicking on Gmail account itself, but it's giving the same command.
Are you giving correct email for the Gmail? Are you giving correct password for the Gmail?
Yes, ma'am.
Try logging into Gmail account and see if there is a click a website given to start using it, because sometimes it asks for that. So if you can open your Gmail and see if there is some email from Overleaf which requires what do you say, authentication.
No, ma'am. Nothing like that in the Gmail.
Let me try. So
It is
you,
giving login error, not registered. When I click login with Google or login with your email.
okay, maybe you can then try to register your account first.
Okay, from the top.
Yes.
Oh.
I don't remember doing it. Maybe you have to register your Google account. First click on register. Register using your Google account.
Yes, ma'am. Now it's okay.
Okay. So after registering, you can log in, I think.
Now it's asking create first project. Welcome to the Overleaf. Create first project.
Yes.
Is it so?
Create first project.
May I click it?
Yes.
Hello. The blank project example. What to click now?
New project.
It's showing blank project, example project, import blank project, I think.
You can use blank project also. So something like this will appear for blank project.
Okay. Now it's asking project name.
Yeah, you can type any name of your choice. Is it done now?
Okay, ma'am. Yes, ma'am.
So you have a blank project now or something like this is appeared?
Like this only.
Okay. So maybe you can remove everything. Let us start from very scratch. So these are what command is given. The thing which I just explained it to you, that this is the preamble part. So is the font enough or should I make it big? Are you able to see the screen? These fonts are
Ma'am, you should make it bigger, ma'am. It's not very visible.
Okay, let me make. Now is it better?
Better now, ma'am.
Okay, all right. So this is a preamble part which I told you. It starts with a document class and what kind of document it is within curly braces. And then what kind of package you are using. This is the title part, title, author, date. And this is your main document. Begin document, end document, and your document has sections, subsections, etc. Whatever you have to type within this. Okay, so this was the basic structure which I had explained. Let me remove all this and try to start from very beginning. So if you have a blank document like this, your first command would be document class, and this is the convenience of using editors. See here, if I type document, even if I don't remember the exact command, I can always choose it. Remove these square brackets. They are for different things which I'm not going to tell in this session. There's something advanced. So within the curly brackets, you can say it is an article type. So actually these square brackets are for font, for formatting your document. Like for example, if you want your document to be 12 font size or 11 font size, etc. So if you want, you can just remove it. It won't matter. With slash, so you have to use a slash, document class without any space, and within curly brackets article. Then if you want to use packages, you can use package command. For now, let us keep it simple and start with our document. This is my document class. Say begin document, and every begin document will end with end document. If I don't use this, see, you see a box here, it says unclosed begin document. It shows what kind of error I might get when I run this document. So whatever is beginning should always end. Otherwise, this is general, what you can say, this is general concept of programming languages. For example, if you are using Fortran or C, C++, if you have a if you begin something, you always have to end it in the end. All right. And now here you can start typing your, say, this is my first LaTeX document. Okay. And if you see here a button, recompile or button, just click on it. It says compiling. And this is what you get in your output. If you see the, let me make it a little bigger. So you get this output. This is my first LaTeX document. So this is what I was saying, that you don't, this is not a vis-a-vis type of document where you type what you get. So what you're typing is this, you are compiling it, and in output you get a different looking document. So I hope your first LaTeX document is ready, and I would like to congratulate those who have prepared their first LaTeX document. You can download this LaTeX document from here. You can say download PDF, or you can download the entire text file from here. Okay, I would just download the PDF and show you how it looks like. So this is my first LaTeX document in PDF format. Can everyone else confirm if they have been able to produce this first document? Okay. Vibha ma'am, were you able to produce this document?
Yes, ma'am.
Okay, great. So now let us start with small exercises. First is how LaTeX handles spaces and paragraphs. So whatever now I'm going to type is within this begin and end document. Okay. So I'll make this end document towards the end. I have already prepared this list, but see, this is my first section. It says spaces and paragraphs. In LaTeX, it does not matter whether you enter one or several spaces after a word. For example, here, if I enter lot of spaces, let us say, and try to recompile it, you would see in output, you do not see so many spaces. See, in output, what you see is a single space. Let me. So it does not matter whether you enter one or several spaces after a word. So by chance, if you have lot of spaces in your document anywhere, in output, you will get single space. This is how LaTeX handles spaces. But if you wanted, let us say, if you wanted lot of spaces here, you would have to give a command to LaTeX to give extra spaces. You could say H space, horizontal space of 5 centimeter. This will give a horizontal space of 5 centimeter. Or if you want, you can use tilde commands. These tilde commands are the commands for spaces. Or you can use a command called space. And if you note here, when I'm saying command, I'm always starting it with a backslash. In LaTeX, all commands, they start with a backslash. I hope this is clear. Now, if I try to compile it, see, after several, there is a gap of 5 centimeter because I have given H space 5 centimeter. I can increase it also, decrease it also. After spaces, again, there is space, extra space, and after a word also, there is, if you notice, there is space. So this is how you give extra spaces in your LaTeX document, either by using H space command, slash space command, or by giving tilde symbols. How lines or paragraphs are handled in LaTeX? So if you want, see, if I did not have an extra line here, if I did not have an extra line here, but this paragraph is starting from new line. If I try to compile it, you will see that LaTeX does not recognize that this is a new paragraph. It starts in continuity. If you want to tell LaTeX that this is the start of new paragraph, then you will have to either type enter, give an extra space here, or you can give a double slash command, or you can give a slash new line command. There are 3 ways of starting the document from a new line. Either, so first is enter. If I say enter, compile it, you see that this line is now appearing as a new line. Or what I can do is, I can give double slash. Now if I try to compile it, see, it is also appearing as a new line. Or I can say slash new line command. If I compile it now, again, an empty line starts a new paragraph with a new line. I hope these 2 points are clear. How to give spaces in LaTeX and how to start lines in LaTeX. So slash new line, 2 double slashes, or an empty line will give a new line to the LaTeX document. So if this is clear, I would like to go to the next basic. So there are 2-3 basics, and then we'll start doing exercises. Special characters, how LaTeX handles special characters. There are few special characters in LaTeX. One is hash, dollar, percentage. I'm not sure about cap, ampersand sign, curly braces, and backslash. So let me remove all these. Let me keep simple commands here. Okay. So these are special commands. So for example, if I want to type 30% in my LaTeX document, see here I've written 30%. If I compile it, my LaTeX document will say 30 and percentage sign is not being shown because these are special characters which LaTeX considers as command. With these special characters, I have to give a backslash. Now, if I say backslash percentage and run it, it shows 30%. So these are few commands which are not visible to LaTeX unless you give a backslash along with them. So for example, curly braces. Now, if I want to write, let us say 43 plus 95 in curly braces. Now, if I compile it, you would see 43 plus 95. The curly braces are not appearing. If I want these curly braces to appear, I have to give backslash commands. Okay, so if I give backslash commands, now try to recompile it. Now these curly braces are coming, they are appearing. And see, 30% and 43 plus 95, they are in single line. Why? Because I have not told LaTeX to start with a new line. If I say new line, then LaTeX will start with a new line. So 30% and 43 plus 95, now it is appearing in a new line because now I have given it a command to appear it, start with a new line. Here, it means everything is written in one single line. Either I have to give a new line command to tell it that this is a new line, or I have to give double slash command to tell it that this is a new line, or I have to press enter to tell it that it is a new line command. Yeah. Double slash will work. Okay. Yeah. Double slash is also not working. Only new line command is working. New line command is working. Okay. So new line commands means that these two are in separate different lines, not in a single line. If I don't write it, these two will appear in a single line. So these are the different special characters which have to be used with a backslash command. Now, if you want to write a backslash in your document, it would always means that this is a command. So it will not appear, it will give an error. So if I try to compile it, it will give me an error. It does not show backslash. See, this backslash is not from here. So this backslash is not appearing. If I want this backslash to appear, I will have to give a command called backslash within dollar signs. I will tell what these dollar signs mean in a while. Okay. Backslash. Now, if I try to compile it, my backslash is going to appear. So these are few commands which you have to remember. Next thing in LaTeX is commenting. Is commenting your documents. So for example, most of you, those who are using coding, they know that in coding, you always try to use comments, like what is this part of the program doing. So for example, in Fortran, you use a C, and C++, I think you use a exclamation mark to say that this is a comment, which is not part of your program, but you use it for your references, that whatever this line below, this line, whatever lines below that line are doing. So that is a commenting part. Commenting means it is part of your program. You can see it, but it will not appear in the output. So for example, let me remove all this. Let us say I have written a document. I have edited it. I want to remove few lines. In Word, what would happen? If you remove those lines, they will remove forever. They will not appear. But in LaTeX, what you can do is you can comment those lines which you think maybe I will use later. maybe they will be useful somewhere else. You don't want to entirely remove it, but you do not want to appear it in your output. You can comment those lines. And for commenting, percentage sign is used. So whatever is after percentage sign, it will not appear in your output. For example, let me compile this document. So in this document, this is an example, and stupid, better, instructive, it does not appear in your output. Why? Because I have commented it by using a percentage sign. Okay, so let me try to write it. This is a commented statement, and I do not want it to appear in the LaTeX document. So this is something which I want to keep it. I don't want to delete it. I don't want to delete it. I want to keep it in my document, but I don't want it to appear in the output. So if I want to do that right now, if I want to compile it, this statement is going to appear in my output. But if I put a percentage sign in front of it, this statement will not appear in my output, but still I can use it later by copying it from here. So this is one more basic feature of the LaTeX document. But let us say you want to comment an entire paragraph. Let us say there are 15-20 lines which you want to comment. Obviously, you are not going to put a percentage sign with each of those lines. So for those, you can use command set called begin, comment, end comment. So whatever text it is appearing between begin and end comment, this text will appear comment, which will not appear in the output. This should appear. So now if I try to compile it, it will give me an error. See, it gives me an error. Why? Because this begin comment and end comment command, it requires a special package called comments package. So after your document class, you have to use this package in order to you being able to use these comment, begin comment and end comment command. Now if I try to compile it, it will not give me an error. See, this part of the code, this part of the program or article, which is within begin comment and end comment, it does not appear in the output. But if you want to use this begin comment and end comment, you have to use a special package called comment package, which should be in your preamble. So just after your document class, you should use this use package comment. So
where this is useful, that we are hiding the comments, like we usually when we write some article or so. So where is this used?
Dr. Viva, this is a very good question. See, for example, I wrote some paragraph here. Okay. And I don't want to entirely delete this paragraph. I am now editing. This is my part of program. This is part of my article. So let us say this. Okay. So this is my research article or whatever. In this research article, while editing, I feel that maybe this line is not suitable here, but I don't want to delete it, because once if I delete it, I can never write those statements back, right? So I don't want to delete it. I want to keep it in my document, but it should not appear in my output file. कि maybe बाद में मैं कहीं यूज करूं उसको, कि हो सकता है हाँ आगे वाले पैराग्राफ्स में यूज हो जाए, या maybe later on I realize no, this is a useful sentence, we should add it. In that case, what I can do is I can comment it for the time being. I can comment it for the time being, and maybe later, if I think it is useful, I can uncomment it. And if I uncomment it, this will appear in my output.
So, ma'am, can we do it like this? We keep this and then we, like we do in the Word, we copy and then we take cut and then paste somewhere else. Or can we do here also?
Yeah.
Like if I'm writing it in the first para, but later on I realize that I want it for the second paragraph, then can it happen?
Yeah, you can cut, Control X, cut it and paste it anywhere else.
Okay, right. That's why we keep it like in the hiding,
Yeah,
hidden
in the comment.
statements.
In the comment. One use of comment is this, that you can use it later if you want.
Okay. But
Filhal,
ma'am, but before submission of the final document somewhere, we have to delete these commenting statements.
No.
So
This
it
will
will
not.
not be appear to someone else.
Oh, it will not appear to someone else. It will only be in your main tech document. It will not appear in your output. This is the beauty.
Okay, right.
You don't have to delete it. You can submit your paper.
But again, if you need to revise that statement, or sometime you have to revise that paper, at that time you can use that comment.
Exactly.
Right. And this will lie with you only.
This will be
not
only
be available.
not
Oh,
viewable to tech editors.
that's really beautiful. That's really beautiful thing to.
You don't have to worry like before submission all comments have to be deleted. No, whatever you are writing, you can write garbage here with comments. It will not matter in your output. What referees or editors are going to review is this PDF file, not this text file. They cannot understand this text file because this is not in a readable format right now. This is a readable format.
That's really beautiful. I was not aware of this thing.
Okay, great. So, yeah. So I hope till here everything is clear. I think I have covered most of the basics. I'll just revise. First basic point is how my LaTeX handles spaces. I told you there are 3 ways to do it. First, by using /h space or /space or tilde signs. So 3 ways of handling spaces. Empty lines can be handled by either giving an empty line in your document or / or /new line command. 3 ways. Special characters have always be used with a \. Because if I try to use these special characters without a \, either my program will give error or these symbols will not appear in my output. So these symbols have to be used with a \. What else? One important point is that all commands in my LaTeX, they start with this \. So if I just type section, this would mean I'm just writing so let me remove this. If I'm just simply writing section, it is part of my document text. Okay, so this section appears here. But if I write this section with a \, it would mean a command. I would have to give a name to this section. Some section. Now, if I try to compile it, it will treat it as a section. It as a command. See, it appears as a section. Some sections. Which section? Number 1. Now, if I want to remove this 1, if I don't want to give this automatic numbering, see, I have not given a numbering here. This numbering automatically appears here. So, in LaTeX, I don't have to worry about giving numbers. This is another very big advantage of using LaTeX. So, section 2, section 3. Okay, so let us say my article has 3 sections, section 1, section 2, section 3. I compile it. LaTeX is automatically going to give numbers to it, first, second, and third. Now, when I'm revising my document, I decide that section 2 should be actually section 1. Okay, so section 2 should be 1, section 1 should be second, and section 3 should be third. Now, if I try to compile it, see, the beauty of LaTeX is that it automatically renumbers these sections. Now, section 2 is the first section, section 1 is the second section, and so on. Okay, so you don't have to manually give these numbers. In Word, what happens? You have to manually give these numbers and see if, rearrange these sections. If you rearrange these sections manually, you have to change the numbers of those sections. Now, if I don't want these numbers to appear, I can always write section with a star sign And if I now compile it, I have section 2, section 1, section 3, but without numbering. I can also change the format of the sections. Like instead of these Arabic 1 and 2, I can also use Roman number. Then I have to use some kind of package. So instead of 1, 2, 3, I can always use Roman numbers 1, Roman number 2, and Roman number 3, or ABC can also be used. So it depends on the style file of the journal. So that is something advanced. I won't cover it here. And within sections, you can give subsections. So subsection of 2. And within subsections, you can give subsections, subsection of 2, and so on. Now, if I try to compile it, LaTeX is automatically going to give these numberings. So 1, then subsection 1.1, and then subsection 1.1.1. And then there is a command to use list of contents. Let me list of contents. Okay, I'll look for those commands. So hope this is also clear how to use sections and subsections by using a backslash command and whatever the name of your section is within the curly brackets. Please do not use any other bracket, otherwise you will get error. You have to use curly brackets with all the commands. Okay, I hope this is also clear. And then the last basic point was how to comment your LaTeX documents. You can comment your LaTeX document by using a percentage sign or by using begin comment and end comment command. But for that, you have to use a package called comment package. Use package, curly brackets, comment. So if this is done, I think we can start with our exercises. Do we have time, Maninder ma'am?
Hanji, excuse me, ma'am. It depends on you, ma'am. If you want to carry on, otherwise we have one more session tomorrow morning, so we can also do practice tomorrow.
I don't know if there are any questions. Then maybe I can take few questions first, and then.
Ma'am, there are no questions yet, but participants are very happy. They are saying that it's very informative. That is, there are no queries at all, but participants are saying that it is very informative and very, very useful session. So I think the things are quite clear to the participant.
Okay. I think only things would be clear to those participants who are trying this. Otherwise, it is very
yes, ma'am. From Mishu Gupta, here is one question.
Okay.
Yes, ma'am. Mishu, ma'am, what is your question?
You have to unmute her, I think.
Yes, ma'am, we are doing.
Hello, ma'am. I just want to know about how to write the symbol of belongs to. Means that if I want to write an equation that x is equals to minus infinity to infinity, and that and this equation is belongs to the real number, then how could I?
Okay. You mean this kind of symbol? Let me.
Means that I have to write x is equals to minus infinity to infinity and belongs to real number, means that R or Z.
This kind of symbol belongs to symbol, right? Nishu ma'am, this kind of symbol you are asking?
Yes, ma'am. Yes, ma'am.
Okay. So, okay. So this is something which we are going to cover in mathematical expressions. Maybe I can give you
exactly
flavor of it. Yeah. So how to handle mathematical expressions? There are three ways to handle mathematical expressions in LaTeX. First is that LaTeX, when you're typing, it does not understand that you are. So if let us say if I write this is a mathematical equation, and if I say x is equal to 2 plus 3 to the power 4, let us say. So I'll come back to the question you have asked, but before that I need to explain how mathematical expressions are written in LaTeX. So if I try to do this and compile it, it will give me an error. Why? Because in LaTeX, you have to specify that now I'm entering a mathematical mode. This is your text mode where you are writing text. Now you have to tell it that you are entering a math mode. And in order to tell that you are entering a math mode, there are three ways to do it. So three ways to write mathematical equations. One is actually not three, there are four. One is use dollar signs. So if I write this within dollar sign, it will understand that this is a mathematical equation and it will appear in my output. So now if I compile it, you would see equation appears. X is equal to, let me make it a little bigger. X is equal to 2 plus 3 power 4. So this is a mathematical equation. Okay. One way is to use dollar signs. Other is to use double dollar signs. Okay. I'll tell what is the difference between both. Third way, see, maybe you would be able to see a little bit of difference yourself from the output. Third way is to use command begin equation and end equation. Now if I type this equation here and recompile it, you would see another equation appearing, but a little different format. And the last way, the fourth way to write equations is by using begin EQN array and end EQN array. So this is used for multiple equations, like you have 5, 6 equations together, then you have to use equation array for it. So let me just remove this for now and concentrate on these three ways to write mathematical equations. So first is using dollar signs. And if you see the output here, in the output, this equation which I have written using single dollar signs, it appears with my text. So my text was 4 ways to write mathematical equations, and in continuity with the text in the same line, I have this equation x is equal to 2 plus 3 to the power 4. So this is one way. If you want to write equations within your text, then you have to use dollar signs. So within dollar signs, so if I miss this dollar sign, my LaTeX will not compile. It will give me an error. I have to close this dollar signs. Within dollar signs, you have to write your equation. Second way is to use double dollar signs. So within double dollar signs on both sides and the equation, you can write an equation, but that equation will be treated as a separate line. So if you see this line, this equation is appearing in a separate line, not in continuity with your text, but it does not have a equation number. If you use begin equation and end equation command to type your equations, then automatically a number appears. So these 3 points are clear, Nishu ma'am? Okay, I think she might be muted by now. Now, in continuity with this, I will come back to Nishu ma'am's question as well. But before that, in continuity with this, I want to show you one advantage of using these LaTeX. So let us say I have another equation in my document, which is x underscore 3, underscore means subscript, is equal to integrate from infinity, okay, to minus infinity. I don't know if it even even make sense. And then I want some C, D, and dx. Okay, something like this. This is my some equation, some random equation. Now if I compile it, this is in superscript. I'll explain all these equations, don't worry. Integrate infinity to minus infinity. Let me keep it simple. So something like this. Okay, x underscore 3 is equal to ck dx. This is my second equation. Now when I'm editing my research paper or article, I decide that this equation should be equation 1 and this equation should be equation 2, let us say. Okay. So right now, x is equal to 2 plus 3 power 4 is equation 1 and x underscore 3 ckd is equation 2. But now for some reason I decide that this equation should be first and the first equation should be second. I copy paste it. Now if I compile it, you would see that LaTeX automatically renumbers my equations. I don't have to manually renumber it. Now this equation is appearing as 1 and this equation is appearing as 2 automatically. And where it is useful? It is useful when you are citing these equations. So here I am citing equation. Let me label it EQX. Okay, anything. Labeling is kind of nickname. You can name it anything. EQY, let us say. So I have labeled my equation x3 is equal to ck dx as EQX, and the second equation x is equal to 2 plus 3 to the power 4 as EQY. I can use anything here, EQ1 or I can say 1 or 2, anything. All right. Now here I am citing in my text. I say here I am citing equation. Now I say refer to equation 1, 2 and then citing equation refer to EQY. Okay, now if I try to compile it, you would see my LaTeX document automatically picks these numbers. So for referring to my first equation, I used the label 1, 2, and for citing my equation number 2, I use label EQY. Now automatically what is happening here, I am citing equation 1 first and then equation second. Now in my document, if I let us say I again decide, somehow I decide कि नहीं ये वाली equation जो है ये तो पहले ही जानी थी, तो ये वाली equation पहली आनी चाहिए और ये वाली दूसरी आनी चाहिए. अगर मैं ऐसा decide करूं तो आप यहाँ पे देखोगे the equation numbers have automatically changed. I don't have to manually change those numbers. Unlike Word may, if you try to rearrange your equations, then in your text, wherever you are citing those equations, you have to manually go and change those numbers. Here you don't have to do that. If this equation has been given label, some label, and you refer to that label anywhere in any document, whatever the number is for this equation, it is automatically going to appear here. You don't have to do it manually. This is one very, very big advantage why I like LaTeX documents. So if this equation has been given number 1, then when you refer to it, equation 1 is going to appear. If this equation has number, let us say 15, then this reference will show number 15 here and so on. I hope this point is clear.
Yes, ma'am, it's clear.
Okay. So now coming to Misha ma'am's question, how I can write equation x belongs to. So for that, again, I have to inform my LaTeX that I'm starting an equation because it is an equation type. Either I can use begin or end equation or simply use dollar signs. Okay. So she says she has to write X is between, X belongs to. So I don't know what is the command for belong to. Let me pull it from the Google. So this is where Google is very useful. How to use LaTeX command for belongs to. So slash in it says. This is something different. So, but what is important here is that you will have to use a package. So you will have to use a package called AMS math. Unless you are using this math package, you will not be able to use that command. X belongs to, so infinity is written as /infty, and let me for temporarily write it as epsilon. It is not epsilon, belongs to infinity to minus infinity, minus infty. Infty. So something like this. X belongs between minus infinity to infinity. So comma and infinity. So Maninder ma'am, if you can unmute Mishu ma'am, I can.
Ma'am is saying that she is able to write, but we will unmute Mishu ma'am.
Mishu ma'am, epsilon is not used. I'm sure it is used. Some other symbol is used. I don't know the command exactly.
Yes, ma'am. Now I understand, ma'am, how to write minus infinity to infinity. That belongs to something symbol of a real number or an imaginary number.
For real, I think it is /r or something. I don't remember. Let us try.
Yes, ma'am. Yes, ma'am.
No, it is not that command. Okay. So, but yeah, this is the way. And what you see here is that you don't see enough spaces. Everything is very can close. So if you want spaces, I told you there's a command to use. You can always give epsilon if you want extra spaces. Now, if you see the output, you will see extra spaces here. Okay. Any other question? But this is the start of using mathematical expressions. So I have partially given a brief introduction how to use mathematical expressions. So maybe I can, shall I think Maninder ma'am, I would like to complete this section and not leave it halfway.
Okay, ma'am. You wish, ma'am.
Okay. So there are some set of commands. I'll show you what each command does. So in mathematical expressions, mostly what you would be using for simple documents is superscripts, and superscript is used by using this cap symbol. So if I want to write 2x superscript 34, I would say within dollar signs 2x cap and curly brackets 34. So if I don't write this 34 in curly brackets and compile it, you would see that 4 does not appear as a power. So if I have to notify LaTeX that this entire thing is within powers or within superscripts. I have to put it within curly brackets. Now if I try to compile it, 34 appears as a power. Similarly, I can write x to the power 3x plus 4, then entire this 3x plus 4 expression should be within curly brackets. Within powers, I can give powers. For example, here I am giving x power 3x power 4. So within powers, I can give powers. Here, if I want, I can give curly bracket or not, because this is a single power. No, this is only 4 single digit power. But if it was a double digit power, I would have to give it within curly brackets. Then it would have been 2x 3x to the power 54 plus 5. Everything power of x. Similarly, subscripts are given by this underscore. So superscripts are given using this cap sign, and subscripts are given using these underscores. And within subscripts, I can give further subscript like x subscript 1, subscript 2, subscript 3 will be written like this. X subscript 1 whole subscript 2 whole subscript 3. Okay. Greek letters. So for integration, the command is /int. And then if I want to give a space, if I don't give a space, both these integrations will be very close. And then integration of pi. So the command for pi is /pi. And these are all case sensitive. So if by chance you write P capital or I capital, your LaTeX will give error. So these are all case sensitive. All are in small letters. If I write capital P, it will mean a different symbol. So if you see this pi will be different. It will be a capital pi. So this is a different pi. Capital /capital Pi gives output like this symbol, and simple pi gives an output like this symbol. Then you can use summation sign by using /sum here. /sum will give you a symbol like this. If I give capital S, the appearance of symbol will be a little different. It will be a capital symbol. Okay, there is no error. There is an error. There is no command called /capital SUM. Okay. And then I can give these things in subscript of my summation. So summation from I is equal to 1, comma j is equal to 1. So everything should be within curly brackets, as I said. And then cap 4 means summation with superscript 4. Then symbol for alpha is /alpha. Some of these commands are very straightforward. This is the formula for finding out the area of a circle. Then how to write epsilon. Trigonometric functions. So y is equal to sin x. If I just write sin x, you'll see the appearance will be different. So this sin x, it appears as a text. So if you notice, and if I write this as a command /sin, now it is a command because I'm using slash. If I now compile it, the appearance is different. Okay. Similarly, the command to use log is /log or /ln. Command to use square roots is /sqrt, and whatever is within the square root should be used within curly brackets. So square root of 2 means I have to write 2 in curly brackets. If I want to use square root of 22, I have to write 22 within curly brackets. And so on. Now if I want 7th root, this is square root. If I want 7th root, I would write 7 in round these square brackets /sqrt, rectangular bracket 7 and curly brackets 2. So this means I'm taking 7th root, and this 2 means I'm taking 7th root of 2, and so on. Okay, so I think I would like to give few minutes to everyone before I move ahead. The list is long. I would like to give few minutes to the participants, those who are actually practicing this, to try these commands on their. So just try using superscripts, subscripts, and these Greek letters. So keep it open. Maybe I'll give 2-3 minutes. Manindra ma'am, will it be okay? And then we can stop doing.
Okay, ma'am. Sure, ma'am. Excuse me, ma'am. Ma'am, the persons who are practicing over here, they have done almost all these commands. And ma'am.
Okay. So Manindra ma'am, I would like to share this exercise with you. I hope you have a WhatsApp group of all the participants.
Yes, ma'am. Of course, we are having.
So I can share what I want to practice, what I have practiced today and what I want to practice tomorrow with the participants. And if they have doubts within those, I can discuss it tomorrow. So I'll share the tech document. What I request everyone is just copy everything from that document and paste it in overleaf and then try to compile it. And try to understand what each command means there. Okay, Manindra ma'am, will that be
okay, right, ma'am. Right, ma'am. You should send it to me. I will be forwarding it in the group itself. Ma'am, thanks a lot, ma'am. It was really an enriching demonstration, ma'am. And there is very positive feedback from the participants also. Dr. Charita Sharma from Ludhiana, she is also saying that it's very informative. And moreover, Mishu ma'am, she has found the command to how to write the real numbers. She may have googled and she has answered that it must be written like /math bb curly brackets are. So ma'am, we are really thankful to you, ma'am, and hope to see you tomorrow in the tomorrow's session. It will start at 10, ma'am. So participants, they are also saying that Dr. Manpreet is saying that we will practice all the commands and then queries will be that is asked in the next session, ma'am. Okay, I thank everyone and moreover the participants, those who have participated actively. We are very thankful to all of you. Hope to see you in the morning session. So I think that enthusiasm will be more because they may not be very prepared for this session, but now they know that what the route is to be followed. So the participation will be much more intense in the next session, ma'am. So hope to see you in the morning session. Thank you very much, ma'am. Thank you.
Thank you so much.